Somewhere, light years beyond our own Milky Way, the very recipe of life may already be written in the stars, waiting for us to notice it. The thought itself feels almost dreamlike, as if the universe has left us a hidden letter, tucked away in the folds of cosmic time, and we are only now beginning to read its first lines. Perhaps those lines are not written in words, but in molecules, in faint glimmers of light carried across unimaginable distances, whispering clues about how life begins. Close your eyes for a moment and imagine if we could reach out, if we could hold that recipe in our hands, it would tell us something about who we are, about where we come from, about whether we are truly alone. This is the doorway, the threshold into one of the deepest mysteries humans have ever dared to ask. NASA has found the origins of life beyond our galaxy, or we are still children wandering in a library whose shelves stretch endlessly, fumbling with the first book. Every great journey begins with a question, and this question might be the greatest of all. The spark of life is not unique to Earth, not even unique to our Milky Way, but instead a universal pattern, like the rhythm of waves upon a shore. It is a question that bends the mind and tugs gently at the imagination, because it forces us to look beyond the comfort of our blue planet and imagine that the same spark could be glowing, quietly, in places so distant they will never see our sun. To enter this mystery, imagine a candle. Its flame trembles in a dark room, fragile yet persistent. That single flame could symbolize the Earth, the only place we know that life exists. Now imagine stepping back so that you no longer see just one flame, but 1,000, and then 1,000,000, each flickering in its own corner of an infinite darkness. This is what scientists must wrestle with. Those other flames represent other beginnings, other Earths, other stories of life unfolding across the universe. NASA, in its grand and patient work, is not merely gazing at stars for beauty's sake. Its telescopes, orbiting high above our atmosphere or stationed on distant mountaintops, are more than machines. They are detectives, listening for whispers, searching for traces of the building blocks of biology hidden in the faint colors of starlight. To most of us, the night sky is a backdrop of twinkling dots. To NASA's instruments, it is a coded message where every shift of color, every dip in brightness, every molecule floating in space carries a story. These telescopes are hunting for molecules that could serve as the alphabet of life, the tiny letters from which nature writes its greatest poems. What makes this search so compelling is the possibility that our beginnings are not singular. If life has cosmic origins, then our story is not just the story of one small planet circling a modest star on the edge of a spiral galaxy. It is a universal story, shared across distances so vast they defy comprehension. In this sense, Earth is not a special exception, but a local chapter in a much larger book. A book that may stretch not only across our galaxy, but into others, far beyond the soft arms of the Milky Way. Consider the implications of this. If life can emerge wherever certain conditions are met, then the cosmos itself is alive with possibility. We, sitting here, breathing oxygen, watching the stars, might be part of a pattern that repeats over and over again across billions of worlds. The great silence we hear when we look into the night sky may not be silence at all, but distance, time, or simply the slowness of our own perception. Even now, on a planet orbiting a star in another galaxy, someone, or something, might be wondering the same thing if we are alone. And yet, the mystery deepens, because we cannot yet prove it. The evidence so far is tantalizing, a mixture of molecules, signals, and patterns that hint but do not yet shout. NASA has caught glimpses of amino acids in meteorites, sugars in distant nebulae, and strange alignments of molecules in galaxies far away. These findings suggest that life's chemistry is not bound to Earth. Whether life itself has already arisen elsewhere remains unknown, a puzzle with missing pieces scattered across the universe. Still, there is a certain quiet comfort in this not knowing. In wondering, in imagining, we participate in the very curiosity that has defined humanity for as long as we have looked at the stars. Each discovery, each whisper of biology in the cosmos invites us deeper into reflection. We are universal if our beginnings are universal. Life itself is not rare, but a cosmic inevitability. These ideas do not have final answers, but they carry a kind of soft gravity, pulling us toward a broader vision of ourselves. Take a moment here. Picture the vastness of space, stretching in every direction, a quilt of galaxies, each one carrying billions of stars. Within those stars, planets spin silently, unseen, some scorched, some frozen, some perhaps just right. On one of them, maybe there is an ocean. On that ocean, maybe waves lap against a rocky shore, and in a quiet tide pool, perhaps molecules are meeting for the very first time, reaching toward the miracle we call life. When you hold this vision, when you let it settle in your mind, the universe feels less like an empty void and more like a grand, patient experiment waiting to bloom. This is the doorway. Beyond it lies a path lined with questions and discoveries, both scientific and philosophical. To ask whether NASA has glimpsed the origins of life beyond our galaxy, we must first pause here, at the threshold, and understand the enormity of what is being asked. We must learn to listen to the faint flickers, to translate the language of molecules into meaning. But the story cannot remain only in the stars. To know whether life truly exists beyond our reach, we must look closer, to the smallest building blocks. The secret of life's beginnings does not rest only in distant galaxies. It begins with the molecules themselves, the simple pieces from which all living things are built. And so, before venturing further outward, we must first step inward, into the chemistry of existence. Life, in all its endless variety, reduces to a surprisingly simple recipe. At first glance, it feels almost impossible to believe. The complexity of forests, oceans, human thoughts, and the whisper of bird wings in the morning all emerge from just 6 basic ingredients. Yet the truth is humbling. Carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. 6 names, 6 tiny players on the cosmic stage, and together they create every living thing we know. Carbon provides the backbone, the flexible scaffold upon which molecules of life are built. Hydrogen bonds with it, forming endless chains and rings, giving molecules their shapes and rhythms. Oxygen fuels reactions, drawing energy from the invisible dance of electrons. Nitrogen carries the potential for proteins, for DNA, for the very structures that fold and refold within every cell. Phosphorus gives us energy in the form of ATP, little packets of power that drive the machinery of life. And sulfur, often overlooked, quietly shapes proteins, stabilizing them so that they can perform their delicate work. To think of these 6 elements is to think of the alphabet. With just 26 letters, humans have written every poem, every scientific equation, every love letter, every story that has ever been told. The letters themselves are simple, their shapes familiar, yet in different arrangements they give rise to entire worlds of meaning. In the same way, carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur form the alphabet of existence. The endless grammar of life is written with them. DNA is a sentence. A cell is a paragraph. An organism is an entire book complete with plot, tension, climax, and resolution. NASA, when it peers into the universe, is not only gazing at stars or searching for new worlds, it is scanning the cosmic shelves for these 6 letters, the primal alphabet scattered through space. Spectrometers aboard telescopes detect the faint signatures of carbon compounds, the glimmers of oxygen, the traces of nitrogen floating in distant atmospheres. To find these elements is not yet to find life, but it is to discover the possibility of words, the raw material of stories waiting to be written. Consider for a moment the Orion Nebula, a vast cloud of gas and dust, a place where stars are born. Within its depths, astronomers have found organic molecules, carbon monoxide, formaldehyde, even methanol, each one a subtle whisper of life's alphabet. Or imagine ALMA, the great array of radio telescopes in Chile, mapping the faint fingerprints of molecules in faraway galaxies. They have traced complex organic compounds, molecules that may be precursors to amino acids, billions of light years away. The scale itself is dizzying. Molecules we once thought fragile and fleeting now appear to be cosmic wanderers, surviving across unimaginable distances. The abundance of these letters scattered everywhere we look means that the story of life is not rare, not a miracle reserved only for Earth, but perhaps the default script of the cosmos. If you scatter letters across the ground long enough, eventually they will spell a word. If molecules swirl in clouds and oceans for billions of years, eventually they spell life. The inevitability of it is both comforting and unsettling. It suggests we are not special, and yet we are deeply connected to everything. Take a quiet breath and think of it this way. Every heartbeat, every breath of air, every sip of water is a rehearsal of ancient chemistry. The same carbon in your body was once inside a star. The same oxygen you inhale may have drifted through interstellar space. The same phosphorus in your DNA could have once been part of the dust around a newborn galaxy. You are not separate from the universe. You are its experiment, its continuation, its living echo. Philosophically, this abundance forces us to reflect deeply. Life's ingredients are everywhere, yet life, as far as we know, has arisen only here. Life may be common, but still hidden from our view, too far, too faint, too unfamiliar to recognize. There may be invisible filters, steps in the process that are so improbable that most of the universe remains silent, waiting for its first flame. The contradiction pulls us in two directions. On the one hand, chemistry seems to suggest inevitability. On the other hand, silence and distance remind us how alone we seem. And yet, there is beauty in this tension. The fact that life may be inevitable does not lessen its wonder. A sunrise is inevitable when the earth spins, yet it still fills the sky with fire and gold. A heartbeat is inevitable if the body lives, yet it still carries the rhythm of love and fragility. Life may be common, but it will never be ordinary. NASA's search for these cosmic ingredients is, in some ways, a mirror of human longing. When astronomers detect methane in the atmosphere of a distant planet or phosphates in the icy plumes of Enceladus, they are not just reporting data. They are whispering back to us. The alphabet is here too. The letters are waiting. Perhaps a story is being written there, quietly, patiently, line by line. Take another moment and let the image settle. Imagine the night sky above you, not as empty, but as overflowing with invisible letters. Each point of light is not only a star, but a sentence waiting to unfold. Each galaxy is not only a swirl of light, but a library of possibilities. If we could listen closely enough, we would hear the quiet scribble of chemistry, the slow writing of stories that began long before Earth ever breathed. This realization changes the way we see ourselves. We are not outsiders peering into the cosmos. We are part of the same script. The ingredients of our bodies are the same ingredients NASA hunts for in the stars. Our very breath is a bridge between Earth and the universe. When you look at your hand, you are looking at carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur, written into a temporary form that thinks, feels, and wonders. You are the universe becoming aware of itself. But ingredients, no matter how abundant, are not enough. A kitchen full of flour, sugar, eggs, and butter will not produce a cake unless something combines them. Molecules, drifting in space, remain molecules unless something draws them together, compels them to arrange in just the right ways, to fold, to replicate, to ignite into the miracle of life. And so, while the discovery of life's alphabet is profound, it leads us to an even deeper question. Who or what does the cooking? When we look up at the night sky, it is easy to think of stars as distant points of light, tiny diamonds scattered across a velvet curtain. They seem permanent, serene, almost indifferent to our small dramas on Earth. But stars are far from passive. Each one is a cosmic forge, a roaring crucible where the elements of life are born. Within their blazing cores, hydrogen atoms are crushed together under unimaginable pressure and temperature, fusing to form helium, releasing energy that will travel across space and time to warm our planet. This process, known as nuclear fusion, is the engine of creation. It is not merely light and heat. It is the universe writing its own chemistry, forging the very atoms that will one day flow through our veins. As stars evolve, their lives follow a rhythm of creation and destruction. Massive stars burn furiously and live brief, brilliant lives, while smaller stars endure for billions of years, quietly sustaining their nuclear fires. In both cases, however, a common truth emerges. Within each star, elements heavier than hydrogen and helium are born. Carbon, nitrogen, oxygen, phosphorus, sulfur, the very 6 elements that form the alphabet of life, are synthesized in the fiery furnaces of stars. They are the products of immense pressure, of particles colliding with furious energy, of processes that are at once violent and creative. And then comes the climax, the star's final act. For massive stars, life ends not quietly, but in cataclysmic supernova explosions. In a moment of unimaginable violence, the star disperses its contents into the void. The atoms forged in its heart, once trapped by gravity, are flung outward, scattering across interstellar space like seeds carried by cosmic winds. Smaller stars, like our own sun, release their enriched outer layers more gently as they age, forming glowing planetary nebulae. In both cases, the result is the same. The universe becomes a garden, sprinkled with the ingredients necessary for life, waiting to find fertile soil. Consider the poetry of this process. Every carbon atom in your body, every oxygen molecule you breathe, every phosphate group in your DNA was born in the heart of a long-dead star. The calcium in your teeth, the iron in your blood, the sulfur that stabilizes your proteins, all were forged in these distant furnaces, ejected into space, and eventually woven into the fabric of planets. In a very real sense, we are the universe reflecting on itself, constructed from the remnants of ancient stellar lives. The stars are not merely observers of our existence. They are its originators, the first authors of the story that continues in every living cell. This alchemy of stars has profound implications for our understanding of life beyond Earth. If the same processes occur throughout the universe, and if stars everywhere produce the same elemental ingredients, then the cosmos may be rich with potential for life. Galaxies far beyond the Milky Way, glowing faintly in telescopic images, may host stars that have completed their own life cycles, scattering carbon, nitrogen, and phosphorus into surrounding nebulae. Planets orbiting those stars could, in time, assemble these ingredients into molecules capable of supporting life. The universe itself, in this sense, is a vast, ongoing experiment in biology, testing the conditions under which life emerges, evolves, and persists. Yet there is an even deeper mystery embedded in this stellar process. The violence of supernova, the chaos of colliding particles, the seemingly random distribution of atoms, all suggest that creation is intertwined with destruction. Life, it seems, is born from catastrophe. Each atom in our bodies carries a story of birth and death, of matter transformed through unimaginable forces. When we inhale, we participate in this cycle. We draw in atoms that may have once been part of a star that exploded billions of years ago. The universe is alive with possibility, and we are living proof of its creative power. It is remarkable to consider that while these stars exploded and scattered their contents across light years of space, some of the material may have traveled beyond our galaxy entirely. Galaxies are not isolated islands. They interact, collide, and exchange matter over cosmic timescales. The seeds of life, carried by interstellar dust and atomic particles, may have been cast into the void, drifting toward other galaxies, waiting for a planet to catch them. It is a humbling and almost magical thought. The atoms that compose us may have originated in distant galaxies, long before our Milky Way even existed, only to find their way here, forming the molecules that would one day animate life. We can imagine the universe as a kind of cosmic garden, where stars act as gardeners, planting seeds of life across time and space. Some seeds fall on barren planets, never germinating. Others are washed away by cosmic storms. Yet on rare worlds with just the right conditions, these seeds might take root, forming the first delicate stirrings of biology. The universe does not guarantee life, but it provides the necessary ingredients, scattered generously, and the right circumstances may be all that is needed for life to awaken. Philosophically, this challenges our sense of uniqueness. If life is seeded across galaxies, then our existence is not a solitary miracle, but part of a larger pattern, a continuity that stretches across unimaginable distances. We are connected not only to Earth, but to every star that has ever burned, every nebula that has ever glowed, every galaxy that has ever swirled. Life is not confined to our planet. It is a phenomenon written into the very chemistry of the cosmos. This perspective also invites a quiet, reflective humility. It asks us to consider that the universe has been experimenting with life for billions of years, far longer than humanity has walked the Earth. The stars have seen epochs come and go, entire civilizations rise and fall, planets form and dissolve, all while continuing to forge the elements of existence. In that context, our lives are fleeting, yet deeply entwined with the ancient processes of creation. Every breath, every heartbeat, every thought is part of this ongoing experiment, a momentary expression of a story billions of years in the making. Yet, even with all this cosmic generosity, the presence of elements alone does not guarantee life. The seeds are there, scattered generously by dying stars, but a seed cannot grow unless it finds soil, water, and a nurturing environment. Hydrogen, carbon, nitrogen, oxygen, phosphorus, and sulfur may drift across galaxies, but without the right conditions to bring them together, they remain inert, potential unrealized. This is where the next stage of the cosmic story becomes crucial. Stars provide the ingredients, the spark, the chemistry, yet the formation of life requires a crucible, a place where atoms can dance together long enough to form molecules, and molecules can organize into the first fragile stirrings of life. Take a slow breath and picture the journey of a single carbon atom. Born in the heart of a star, ejected by a supernova, traveling across light years of cold, empty space, eventually captured by a swirling cloud of gas and dust. That cloud collapses under gravity, forming a new star and orbiting planets. On one such planet, the carbon atom becomes part of an organic molecule, eventually joining other molecules to form the scaffolding of a living cell. The journey is long, improbable, and extraordinary. Yet it is a journey that billions of atoms undertake every moment across the universe. It is this interplay between the abundance of ingredients and the necessity of precise conditions that makes the search for life so fascinating. NASA and other space agencies are not merely cataloging elements, they are tracing the pathways by which those elements might come together, searching for planets and environments where the chemistry of life could ignite. Each discovery, whether of a distant exoplanet, a complex molecule in a nebula, or traces of organics in a meteorite, is a clue in this grand cosmic puzzle. The stars, in their alchemy, remind us that creation is both ordinary and miraculous. The processes that forge the elements of life are the same processes that have been occurring since the universe was young. They are predictable in the sense of physics and chemistry, yet unpredictable in the way those elements will eventually combine to form life. Every star that dies is a potential nursery for life elsewhere. Every galaxy is a sprawling library of chemical possibilities. The universe is patient, vast, and tireless, and it has been practicing this form of cosmic creation for eons. And so we arrive at a contemplative pause, at a gentle understanding that while stars scatter the seeds of life generously across space, seeds alone do not guarantee a forest. They provide the potential, the raw materials, the spark. But the miracle of life requires assembly, connection, and nurturing. Stars are the cosmic alchemists. Yet the recipe for life needs a kitchen, a stage, a cradle where atoms can meet, molecules can interact, and biology can emerge from chemistry. As we follow this thought, we prepare to look next not at the stars themselves, but at the spaces between them, at the clouds of gas and dust, where chemistry dances in slow motion, where the ingredients scattered by ancient stellar fires begin their quiet work, inching toward the possibility of life. Space is often imagined as a vast emptiness, a silent void stretching between stars, planets, and galaxies. But NASA's discoveries suggest otherwise. Far from being empty, the cosmos behaves like a vast, patient chemistry laboratory, where reactions unfold slowly, quietly, over millions and even billions of years. Here, in the cold darkness of interstellar clouds, where temperatures plummet to just a few degrees above absolute zero, molecules come together in delicate dances that may one day give rise to life. Imagine a nebula, a glowing cloud of gas and dust, drifting gently through space. Within it, hydrogen and carbon atoms collide, adhere, and form the simplest molecules. Some of these molecules, like carbon monoxide or formaldehyde, are mundane by earthly standards, but they are the first notes in a symphony that could crescendo into life. Over time, these molecules combine into ever more complex forms. Amino acids, the building blocks of proteins, sugars essential for energy and structure, and even nucleobases, the precursors to RNA and DNA. Here, amid the icy dust grains and faint starlight, nature performs an experiment repeated across the universe, where the raw materials of life are synthesized in slow, invisible rhythms. It is extraordinary to think that such complexity can arise in what appears to be emptiness. On Earth, chemists conduct experiments in laboratories, controlling temperature, pressure, and concentration to coax molecules into specific reactions. In space, however, there are no test tubes, no equipment, no hands guiding the process. Instead, there are only dust grains, cosmic rays, and photons of starlight providing energy. And yet, from this apparent chaos emerges order, a kind of quiet creativity. The universe itself is the chemist, its laboratory stretching across light years, its reactions measured not in seconds, but in millennia. Telescopes such as ALMA, perched in the high deserts of Chile, and JWST, orbiting far above Earth's atmosphere, act as our eyes and ears in these laboratories. They do not merely capture images of stars and galaxies, they detect the faint spectral fingerprints of molecules, the chemical signatures imprinted in the light that travels across space. Through these instruments, astronomers have identified amino acids, sugars, and other organic molecules not only in our galaxy, but in galaxies billions of light years away. The implication is staggering. The chemistry of life is not confined to our solar system. It is universal, pervasive, perhaps even inevitable. Take a moment to picture the scene. A tiny dust grain floats in the darkness of a nebula, coated in ices of water, methanol, and ammonia. Photons from a nearby star strike the grain, providing the energy for atoms to rearrange and bond. Slowly, over thousands of years, a complex molecule forms on its surface, stable and ready to drift through space. This is not science fiction. This is the reality that astronomers are uncovering. These molecules, minute and fragile, are the precursors to life, the alphabet letters scattered across the cosmos, waiting for the right conditions to compose words, sentences, and stories. What makes this even more mesmerizing is the universality of the process. The same physics and chemistry apply in nebulae across different galaxies. The carbon in a distant galaxy may undergo the same reactions as the carbon in the Orion Nebula or in the clouds that once formed our own solar system. In this sense, the universe is performing the same experiment over and over with slight variations across countless locations. Life's recipe is not written in a single book or on a single page, but in the very structure of matter itself. This realization challenges the way we think about life and its rarity. If the ingredients of biology, amino acids, sugars, nucleobases, can form spontaneously in the vacuum of space, then perhaps life is not an improbable accident. Perhaps it is a natural consequence of chemistry, a pattern that will emerge wherever the conditions allow. The universe becomes less a cold, indifferent void and more a patient, tireless alchemist, preparing the raw materials of life over eons, waiting for the right stage to animate them. Reflect for a moment on the interconnectedness of it all. Every atom in your body has traveled through space in ways unimaginable. Some may have been part of a distant star, others part of interstellar clouds where molecules assembled slowly, patiently, long before the Earth existed. When life first emerged here, these cosmic molecules may have been carried down to the primordial oceans on meteorites, contributing to the first flickers of biology. The chemistry that NASA detects in distant nebulae could mirror the processes that occurred in our own solar system. A gentle reminder that we are connected to the cosmos not only physically, but chemically. It is both humbling and beautiful to consider. The universe does not require intelligence to create complexity. It does not demand intention to arrange molecules into meaningful patterns. Yet, through the persistent application of physical laws, through countless collisions, reactions, and interactions, it produces the precursors to life in a manner that seems almost deliberate, almost conscious, as if nature itself has been scripting the first lines of a story whose ending we have yet to read. And there is something meditative about this slowness, this patience. In a human laboratory, we expect results within hours, days, or at most years. In interstellar space, the pace is measured in millennia, in tens of thousands of human lifetimes, in epochs that span the rise and fall of countless civilizations. There is a quiet rhythm here, a sense that creation does not hurry. Molecules form, drift, rearrange, and wait. The universe gives itself time to perfect the recipe. Yet, as profound as this is, the formation of molecules alone is still not life. These molecules are potential, not actuality, letters without sentences, seeds without soil. They must eventually find a home, a place where they can combine, replicate, and begin the delicate dance that gives rise to living systems. A cloud of amino acids in a nebula is a beginning, but not yet a story. A sugar molecule in the darkness is a promise, but not yet a miracle. The stage must exist, and it must be ready to receive these chemical seeds, to nurture them into something more. NASA's observations remind us that we live in a universe rich with possibilities. Every detection of an organic molecule is a whisper from the cosmos, an invitation to imagine what might happen if these molecules find themselves on a hospitable planet. These whispers encourage us to consider that Earth may not be unique in nurturing life, that the chemistry of biology could be unfolding in countless places we have yet to see. In this light, our search for extraterrestrial life becomes not a hunt for a singular miracle, but an exploration of a universal pattern, a story that the universe is telling across space and time. The implications are staggering. If molecular precursors of life exist throughout the cosmos, then the potential for life extends far beyond our imagination. Galaxies billions of light years away may be performing the same experiments we observe locally, assembling molecules, storing energy, and edging ever closer to the spark of life. Perhaps somewhere in those distant galaxies, conditions have aligned perfectly, and life has emerged, not as a possibility, but as a reality. It may be flourishing, evolving, and adapting in ways we cannot yet fathom, while we gaze upward in wonder, slowly piecing together the story of our own origins. And so we arrive at a quiet, contemplative understanding. The chemistry of life is not isolated, not an earthly anomaly, but a cosmic process. Nebulae are laboratories, galaxies are experiments, and the universe itself is a teacher, showing us how molecules can arrange themselves into complex structures over incomprehensible spans of time. Yet these molecules, however extraordinary, are still waiting for the right conditions, the right planetary stage, to form the first cells, the first reactions that will ripple forward into the miracle of living systems. Molecules alone are seeds, scattered generously by the alchemy of stars, but seeds do not guarantee a forest. They require nurturing, a place to grow, and circumstances that allow chemistry to unfold into biology. The next chapter in this cosmic story will explore those cradles, those delicate environments where atoms and molecules meet, and under the right conditions, life begins to stir. Take a deep, slow breath and let the thought linger. Imagine the vast, cold clouds of gas and dust in distant galaxies, drifting silently, their molecular contents assembling over millennia. Each cloud, a potential womb, a quiet promise, a possibility that the universe may not only harbor life, but be actively preparing it wherever it can. And remember that we, here on Earth, are the inheritors of that cosmic chemistry, living proof that the universe's laboratory can produce something extraordinary. To truly understand the origins of life, we must turn our gaze from the stars themselves to the worlds that form around them. Planets are more than rocks drifting in space. They are nurseries, places where chemistry and physics meet to create the conditions for life to awaken. Each planet is a delicate experiment, shaped by gravity, time, and chance, and each carries the potential to harbor life if circumstances align just so. Imagine a newborn star, radiant and blazing in a cloud of gas and dust. Around it, a flattened disk begins to spin, a cosmic carousel of particles circling in silent harmony. Within this swirling disk, collisions occur, first gentle, then more forceful, as dust grains stick together, forming clumps, and clumps merging into larger bodies. Over millions of years, these accumulations grow into planetesimals, the building blocks of planets, and eventually into fully formed worlds. The process is messy, chaotic, and yet extraordinarily precise. Gravity guides the dance, shaping orbits, determining distances from the star, and influencing surface conditions. Most of these newborn worlds will not be hospitable to life. Some will orbit too close to their star, scorched by relentless radiation and searing heat. Others will dwell too far, frozen in the outer reaches, where oceans are locked in ice and chemical reactions crawl at glacial speed. But among these extremes lies a narrow band known as the habitable zone, the gentle region where temperatures are just right, where liquid water can flow, and where the alchemy of life may be possible. Water, the universal solvent, is not merely a convenience. It is the stage upon which molecules dance, forming the intricate networks that lead to living systems. Take a moment to imagine a planet within this habitable zone. Its surface glimmers with oceans, its atmosphere breathing faintly in response to heat from the star. Beneath the waves, amino acids and sugars, delivered perhaps by meteorites or synthesized on the planet itself, float and collide. Molecules encounter one another, combining into larger, more complex structures. Reactions proceed slowly, meticulously, over millions of years, building toward the first tentative spark of life. The planet becomes a theater, a laboratory, a cradle where the chemistry of life transforms into biology. NASA's missions, from telescopes scanning distant exoplanets to probes investigating icy moons in our solar system, seek to uncover these cradles. They measure atmospheres, look for water vapor, detect organic molecules, and analyze the physical conditions of distant worlds. Each discovery adds a piece to the puzzle, revealing not only where life might exist, but also how the universe distributes its potential. Some planets are bathed in constant sunlight, providing energy for chemical reactions. Others hide beneath thick ice, shielded from radiation yet warmed by internal heat. Each scenario offers a different path toward life, and the diversity of planetary environments suggests that the universe may experiment endlessly, seeking conditions in which biology can arise. The idea that planets are nurseries reframes how we think about our place in the cosmos. Earth, with its oceans, atmosphere, and temperate climate, may feel unique, but perhaps it is merely one example in a vast sequence of planetary rehearsals. Across the galaxy and beyond, other worlds may be conducting their own quiet experiments, testing the combinations of elements and molecules, seeking that rare arrangement that sparks biology. In this sense, life may not be a singular miracle, but an ongoing possibility, patiently unfolding wherever conditions permit. Water, in particular, plays a central role in this cosmic stage. Its unique properties allow molecules to move, interact, and fold into the complex structures necessary for life. It facilitates chemical reactions, stabilizes molecules, and acts as a medium for the transport of energy and nutrients. Without water, the dance of molecules would stall, frozen in isolation. With it, chemistry becomes choreography, and the first stirrings of biology can emerge. This is why NASA and other space agencies are so eager to find planets with oceans or evidence of water, whether on the surface or beneath ice-covered shells. A planet with water is not just a world. It is a potential cradle for life, a setting in which the universe's chemistry can take its next step toward biology. Consider the icy moons in our own solar system, such as Europa and Enceladus. Beneath their frozen exteriors lie oceans that have persisted for eons, warmed by tidal forces and internal heat. Within those oceans, chemical reactions may proceed, isolated from the chaos of the surface, yet vibrant in their own right. NASA's spacecraft have detected plumes of water and organic molecules erupting from these moons, tantalizing hints that chemistry is active, waiting for the right conditions to bridge the gap from molecules to life. These moons remind us that nurseries do not have to look like Earth. They can be hidden, subtle, and still profoundly potent. Expanding this vision beyond our solar system, thousands of exoplanets have now been discovered orbiting distant stars. Some are rocky, some gaseous, some orbiting in zones where temperatures could allow liquid water to persist. Telescopes like JWST are beginning to characterize their atmospheres, looking for signs that life might be possible. The sheer number of these worlds suggests that habitable planets are not rare, that nurseries may exist in unimaginable abundance, each one a potential stage for the emergence of biology. If so, our understanding of life shifts dramatically. Earth may no longer be the sole center of life's story. It may be one chapter among countless others, each written with the same universal chemistry, but unfolding in its own unique narrative. Philosophically, the idea of planets as nurseries encourages a humbling perspective. The universe is not merely a backdrop for our existence. It is an active participant in life's potential, crafting conditions and distributing opportunities for chemistry to become biology. Our planet's oceans, atmosphere, and magnetic field all play roles in this cosmic theater, but they are part of a larger pattern. Across billions of galaxies, similar conditions may arise independently, offering the possibility that life is not an accident, but a recurring phenomenon, a cosmic melody played in different keys throughout the universe. This vision also invites quiet wonder about the fragility and rarity of life, even within these nurseries. Just because a planet has water and organic molecules does not guarantee that life will emerge. The formation of cells, the development of metabolism, the emergence of replication, these are all delicate processes, each with countless potential points of failure. Yet, the more nurseries the universe provides, the greater the chance that one or many will succeed. Each planet is a roll of the cosmic dice, and across the vastness of space, it is almost inevitable that some will win. Take a slow, contemplative breath and imagine one of these distant nurseries. Picture a rocky world bathed in the light of a sun unlike ours, oceans shimmering beneath clouds of alien composition, chemical reactions unfolding invisibly beneath the waves. In some corner of this planet, molecules are colliding and forming structures, exploring combinations that may eventually become life. Across the universe, countless planets perform similar experiments, quietly, patiently, without fanfare or announcement. Each is a possibility, a chance, a rehearsal of what we see here on Earth. And so we begin to see Earth not as the sole miracle, but as part of a grander theater. Our planet may be one successful outcome among innumerable trials, a place where chemistry found the right conditions to blossom into biology. Across the cosmos, other planets may be rehearsing similar processes, some long completed, some still in progress. This realization does not diminish the wonder of life on Earth. Rather, it amplifies it, placing our existence within a universe actively experimenting with life, patiently, endlessly, across space and time. Yet, as remarkable as these planetary nurseries are, even they cannot guarantee the emergence of life. They provide the environment, the stage, the conditions for chemistry to flourish, but life requires one more essential element: organization, a process to assemble molecules into functioning systems capable of sustaining themselves. Without this step, planets remain nurseries in the most literal sense, places prepared for life, but where life has yet to take root. The next chapter of our journey will explore how these conditions converge to form the first cells, the delicate balance that allows molecules to organize into living systems. And if such cradles exist beyond our galaxy, in ways we cannot yet observe, then perhaps Earth is not the only successful performance of this cosmic theater. Perhaps it is one rehearsal, a fleeting act in a vast drama that has been playing out for billions of years, across countless planets and galaxies. The thought is both humbling and exhilarating, a reminder that life may not be unique to this world, but a potential woven deeply into the fabric of the universe itself. The universe is vast, stretching across billions of light years, a tapestry of galaxies, stars, and planets so immense that human comprehension falters. And yet, somewhere in that immeasurable expanse, life may be quietly stirring, forming, evolving, or perhaps already flourishing. But how could we, from our small vantage point on Earth, ever hope to detect it? How do we search for whispers of life across distances so great that light itself takes millennia to arrive? This is where NASA's cosmic detectives come into play. Instruments of observation and analysis that pierce the darkness, seeking the faint signatures that might reveal life beyond our solar system. NASA's telescopes are not mere cameras capturing beautiful images of stars and galaxies. They are forensic instruments, carefully tuned to read the subtle fingerprints left by molecules in the light they absorb and emit. Every atom, every molecule interacts with light in a specific way. When starlight passes through a planet's atmosphere, molecules absorb certain wavelengths, leaving patterns that betray their presence. By decoding these patterns, astronomers can identify water vapor, carbon dioxide, methane, oxygen, and other compounds, subtle clues that could indicate the presence of life. Consider JWST, the James Webb Space Telescope, suspended far above Earth's atmosphere, its mirrors catching light that has traveled across eons and unimaginable distances. JWST can analyze the faint glow of a distant exoplanet, splitting the light into a spectrum, revealing the chemical composition of its atmosphere. Imagine looking at a tiny point of light, so small it is barely distinguishable from the darkness, and knowing that hidden within that light are the signatures of molecules that could support life. It is like reading the faintest fingerprints on a page written billions of years ago, deciphering a story written in the language of chemistry and light. ALMA, the Atacama Large Millimeter Submillimeter Array in Chile, offers another perspective. It maps cold clouds of gas and dust where stars and planets are forming, detecting the faint emissions of molecules that are the precursors of life. ALMA has revealed the presence of amino acids, sugars, and other organic compounds in interstellar space, confirming that the building blocks of life are not unique to Earth. These discoveries reinforce the idea that life's chemistry is a universal phenomenon, and that the universe itself is a vast, ongoing experiment in biology, patiently assembling the components of life wherever it can. Through these instruments, NASA acts as a cosmic detective, piecing together clues from billions of years of history. Each molecule detected, each atmospheric composition analyzed, is a piece of evidence, a hint that life may not be confined to our tiny blue planet. For example, methane and oxygen detected together in an exoplanet's atmosphere could suggest biological processes, because on Earth, these gases are largely produced by living organisms. The presence of such biosignatures, even if indirect, offers a tantalizing glimpse into possibilities beyond our imagination. Think of it like listening for whispers in a vast, darkened hall. The whispers are faint, almost imperceptible, yet they carry profound meaning. Each detection, no matter how small, expands our sense of what home might mean. Perhaps our galaxy is not a lonely island of life. Perhaps planets orbiting distant stars are nurturing chemistry that mirrors our own, and the stage for biology is far more common than once believed. Each discovery invites us to imagine that life is not an accident, but a recurring possibility woven into the fabric of the cosmos. The work of NASA's cosmic detectives is also a study in patience and precision. Light from distant stars and planets is dim, distorted by dust and time. Telescopes must gather this light carefully, sometimes for hours, days, or even weeks, to tease out the subtle signals that hint at molecules. Data is collected and analyzed, models are built and refined, and theories are tested against observations. Each detection is scrutinized, debated, and confirmed, because the stakes are nothing less than understanding whether life is a universal phenomenon or an extraordinarily rare occurrence. This pursuit has philosophical weight as well as scientific significance. If molecules indicative of life are found on multiple exoplanets, it challenges the notion that Earth is the sole cradle of biology. It suggests that the processes that gave rise to life here may be replicated elsewhere, across the galaxy, or even in other galaxies entirely. Humanity's sense of uniqueness is tempered but not diminished. Instead, we are invited into a larger narrative, one in which our existence is part of a universal pattern, a story that spans light years and eons, connecting us to worlds we may never touch, but whose chemistry mirrors our own. Imagine a distant exoplanet, orbiting a star hundreds of light years away. Its atmosphere is rich in water vapor, a trace of methane, perhaps even oxygen. JWST records the faint spectrum of that light, sending data back across the void to Earth. Scientists analyze the patterns, comparing them to models of planetary atmospheres and chemical processes. They may never directly see the surface of that planet, yet they begin to piece together its story, inferring the potential for life from the molecules suspended in its air. It is detective work of the most subtle and profound kind, a study in the whispers of the universe, carried across incomprehensible distances. These cosmic investigations also invite reflection on time itself. Light detected today may have begun its journey before human civilization existed. The molecules we analyze could reflect conditions from millions or billions of years ago. In a sense, telescopes allow us to look into the past, tracing the development of chemistry and planetary environments across cosmic history. Every detection is a dialogue with the universe, reaching backward in time to uncover the processes that may have seeded life elsewhere. NASA's cosmic detectives also remind us of the fragility and serendipity involved in life's emergence. Detecting a biosignature does not guarantee life, just as finding a seed does not ensure a forest. It is a hint, a clue, a fragment of a larger story that may be unfolding across space and time. Yet each clue enriches our understanding, allowing us to map the possibilities, to imagine the ways life might arise, and to recognize the universe as a living laboratory, endlessly experimenting with the chemistry of biology. There is also a quiet, almost meditative wonder in this process. To think that light traveling for hundreds of light years can carry the chemical signature of a distant world is humbling. It is as if the universe itself is sending messages across time, whispering to us through the medium of starlight, offering glimpses of processes that began long before our sun formed, long before humans walked the earth. Each discovery is a dialogue, an invitation to imagine, to reflect, and to wonder at the immense patience and creativity of the cosmos. And yet, even with all these detections and analyses, traces alone are not enough. Molecules in an atmosphere hint at life, but they do not confirm it. They are signs pointing toward possibility, clues that guide us toward a deeper understanding of where biology might emerge. To truly comprehend the origins of life, we must follow the trail even further, tracing it not only across space, but also through time, into the earliest moments when molecules first coalesced into living systems. The search does not end with detection. It continues into understanding, into reconstruction of the processes that transform chemistry into biology. Take a slow, reflective moment and picture this journey. A photon leaves a distant star, passing through a planet's atmosphere, carrying with it the fingerprints of molecules that could hint at life. That photon travels across light years, finally reaching a telescope orbiting Earth. Scientists receive the signal, analyze it, and slowly piece together a story, a possibility, a whisper from a world we cannot touch. In that instant, across unimaginable distances, the universe speaks, and we listen, learning that the ingredients for life may be more widespread than we ever imagined, that the potential for biology is woven into the fabric of space itself. NASA's cosmic detectives teach us that the universe is not silent, nor indifferent. It is a storyteller, leaving faint traces of its experiments, waiting for minds capable of noticing, interpreting, and imagining the possibilities. Every detection is a step closer to understanding whether life is a solitary phenomenon or a common expression of cosmic chemistry. It expands our sense of home, suggesting that the stage for life may extend far beyond the Milky Way, into regions of space we have only just begun to glimpse. And yet, as profound as these discoveries are, they are only the beginning. Traces of life are signs, but they point us towards something deeper. To understand whether life exists elsewhere, we must trace these molecules through time, back to the processes that assemble them into cells, metabolic networks, and self-replicating systems. The search moves from chemical fingerprints to the heart of biology itself, from clues to origins, from hints to understanding. We often think of fossils as fragments of life preserved in stone, relics buried in the soil, silent witnesses to the creatures that walked the earth long before we were here. Yet fossils exist not only in rocks on our planet, but also in the very fabric of space itself. The remnants of ancient chemistry, and perhaps the earliest stirrings of life, drift across the universe, carried on meteoroids, comets, and cosmic dust. This is not mere speculation. It is a possibility suggested by the extraordinary discoveries of NASA and other space agencies. Meteorites that fall to Earth provide a tangible connection to the ancient universe. Some of these rocks, fragments of asteroids, or even distant planets, carry molecules that predate the formation of our solar system. Amino acids, the building blocks of proteins, have been found embedded within these spacefaring stones, their structures intact after billions of years traveling through the void. The remarkable aspect is that these molecules are older than Earth itself, formed in the interstellar medium or within the fiery interiors of dying stars long before our planet coalesced from the solar nebula. In a very real sense, they are fossils of cosmic chemistry, relics that carry a story from before our world existed. Imagine holding one of these meteorites in your hand. The stone is cold and heavy, unremarkable to the touch, yet it contains the ancient handwriting of the universe. Embedded within its crystalline structure are amino acids, tiny molecular letters that could, under the right circumstances, spell the story of life. They are silent witnesses to chemical processes that occurred long before humans existed, before the Earth had oceans, before the first cells flickered into being. These molecules have traversed unimaginable distances and timescales, carrying with them the legacy of creation itself. NASA's analyses of these meteorites reveal a tantalizing fact. Space is not barren or inert, but a repository of ancient chemistry. Amino acids, sugars, and other organic compounds have been detected in meteorites such as Murchison, a stone that fell in Australia in 1969. These molecules are not simple or mundane. They include some that are rare on Earth, hinting at chemical diversity that the planet itself had never seen before. The significance is staggering. It suggests that the components necessary for life are not confined to Earth, but are scattered across the cosmos, transported on rocks that drift between worlds, perhaps even between stars. If these space fossils can survive the harsh journey through interstellar space, enduring radiation, vacuum, and extreme temperatures, then it becomes plausible that life's seeds, or at least the ingredients for life, can be distributed widely. A meteorite carrying amino acids might crash onto a young planet, delivering a chemical payload that contributes to the formation of the first biological molecules. In this way, chemistry, and possibly biology, can leap across the universe, connecting distant worlds in an invisible web of chemical potential. Take a quiet moment to consider the implications. Every molecule that makes up your body may have a story that predates Earth itself. Some atoms may have been part of ancient stars, forged in nuclear furnaces, scattered across space, and later incorporated into the rocks that delivered them to our young planet. In this sense, the Earth was not the birthplace of life's chemistry, but a recipient, a stage on which ancient molecular narratives could unfold. Fossils in space suggest that life's story may not have begun here, but has a history far older and more expansive than we have ever imagined. These findings provoke a profound shift in perspective. If molecules essential for life can travel across space, enduring the vacuum and radiation of interstellar travel, then the universe may be more interconnected than we perceive. Life's ingredients are not isolated on one planet or in one solar system. They are mobile, carried by rocks, dust, and comets across light years. The cosmos itself becomes a network of potential, where chemistry can move, mix, and perhaps ignite life in multiple locations. Earth, then, is not an isolated experiment, but part of a vast laboratory of worlds sharing the same chemical heritage. The metaphor of fossils in space also stretches our imagination. Fossils on Earth are remnants of life that once existed, tangible evidence of what came before. Space fossils, however, are evidence not of life itself, but of the potential for life, molecular traces that hint at processes that could lead to biology. They are whispers from a universe that is ancient and patient, carrying chemical knowledge across eons and light years. Holding one in your mind's eye is like listening to a voice from the distant past, one that tells of stars, nebulae, and planets long gone, yet whose molecules continue their journey, seeking conditions where life might take hold. The presence of these ancient molecules also raises profound philosophical reflections. If life, or at least its precursors, exists beyond Earth, then the story of life is not a local tale, but a cosmic narrative. It suggests that the emergence of biology may be a recurring theme, a motif repeated wherever the ingredients meet the right conditions. Earth, with its oceans and atmosphere, may be one verse in a poem written across the galaxy, part of a sequence of experiments conducted by the universe itself. Fossils in space hint at the possibility that life is not an anomaly, but a fundamental consequence of chemistry under the right circumstances. And there is a poetic resonance to this idea. We often think of life as fragile, limited to a single planet, dependent on luck and circumstance. Yet space fossils remind us that chemistry is robust and persistent, traveling vast distances, surviving extremes, and enduring long before biology emerged. Life's potential is ancient, mobile, and patient. The universe has been experimenting for billions of years, sending its chemical messengers from star to star, from galaxy to galaxy, perhaps in search of environments where biology can emerge. NASA's discoveries of amino acids and other organic molecules in meteorites suggest that we are only beginning to understand the scale and complexity of these processes. Each rock that falls from the sky is a message from the cosmos, a tangible connection to the chemistry of distant stars and interstellar clouds. Each molecule within that rock carries a history, a narration, a narrative of formation and eventual delivery to a planet capable of nurturing life. Taken together, these findings hint at a universe in which life's potential is not confined to a single world, but spread widely, patiently, awaiting the right conditions to manifest. The implications extend even further. If molecules can survive journeys between stars, they could also traverse the vast distances between galaxies. The seeds of life, or at least the ingredients for it, may leap across the universe, carried on comets or cosmic dust, to initiate biology in entirely separate galactic neighborhoods. This possibility, while extraordinary, is not ruled out by current evidence. The chemical continuity we observe in meteorites and interstellar clouds supports the notion that life's building blocks are remarkably resilient, capable of enduring extremes and crossing boundaries that once seemed insurmountable. Take a slow, meditative breath and envision this cosmic journey. A molecule forms in the icy heart of a distant nebula, billions of years ago. It is incorporated into a small asteroid which drifts through interstellar space, passing near stars and comets, enduring the void. Eventually, it collides with a young planet, delivering its chemical cargo to a primordial ocean, where molecules mingle and reactions begin. This is not science fiction. It is a plausible scenario suggested by the evidence of ancient molecules in meteorites. Space itself becomes a messenger, carrying the potential for life across unimaginable distances. And so, we arrive at the threshold of one of the most daring ideas in the story of life: panspermia. If molecules, or perhaps even primitive life forms, can survive the rigors of space travel, then the universe may be more like a network of interconnected laboratories, sharing the ingredients and potential for life across its vast expanse. Earth may not be the origin of life, but a recipient, a stage on which ancient chemical stories from distant corners of the cosmos unfold into biology. The fossils in space, silent and ancient, invite us to imagine a universe in which life's seeds are not confined, but scattered, traveling, waiting, and perhaps thriving wherever conditions allow. Life on Earth feels intimate and grounded. It unfolds in oceans, forests, deserts, and skies, a story we experience firsthand. Yet the discoveries of ancient molecules in meteorites and the chemical activity in distant nebulae invite a far more expansive vision. Life is not bound to a single planet, a single star, or even a single galaxy. Panspermia, sometimes called the cosmic pollination theory, suggests precisely that. Life may drift across the universe, carried like pollen on invisible winds, spreading seeds of biology wherever the conditions allow. Picture a comet, a frozen wanderer cast out from the outskirts of a stellar system. Its icy surface glimmers faintly in the cold, dark void, concealing microscopic life forms or hardy spores embedded within. Over eons, this comet drifts past planets, through asteroid belts, and across the immense emptiness between stars. Radiation and vacuum batter it relentlessly, yet some resilient microorganisms survive, shielded by layers of ice and rock. Then, in a chance encounter, the comet collides with a young planet, delivering its hidden cargo to a fertile environment. Molecules mingle, reactions begin, and life may stir anew. This is the essence of panspermia, the universe acting as both gardener and courier, distributing life's potential across unimaginable distances. NASA and other research agencies have investigated whether life can survive such journeys. Experiments show that certain extremophiles, microorganisms capable of withstanding extreme cold, radiation, and vacuum, can endure conditions similar to those in space. Spores of bacteria have survived years in orbit, shielded by layers of rock or ice. While no one has yet found living organisms traveling between stars, these experiments demonstrate that the mechanism is plausible. The universe has the time and the scale necessary to allow life, or at least its precursors, to leap across the void, carried by comets, asteroids, and even fine cosmic dust. Imagine the universe as a vast orchard, stars as trees, and comets and asteroids as wind-borne pollen. Seeds of life may have been dispersed countless times over billions of years, spreading in multiple directions, traversing the galaxy, and perhaps even venturing between galaxies. Each world that receives these seeds becomes a potential stage for biology, a place where molecules assemble into cells, metabolic networks develop, and life begins its intricate dance. Earth may be one of countless theaters where this cosmic experiment is playing out, a recipient of seeds that originated long before our sun even existed. The implications of this idea are profound. If life can spread in this way, then all living organisms on Earth may share a deeper, more ancient kinship than we typically imagine. We might not be just cousins in the narrow sense of biology, but distant relatives connected across light years, fragments of the same ancient tree of life, rooted not on one planet, but in the cosmos itself. Every organism, from the simplest microbe to the largest whale, could carry a lineage that began in the interstellar medium, in comets drifting silently through space, or on a planet in a distant galaxy. In this view, life is not a local phenomenon, but a cosmic heritage, an inheritance shared across space and time. Yet the theory also invites reflection on fragility and chance. For life to successfully travel from one world to another, conditions must align perfectly. Microbes must survive ejection from a planet, endure years or millennia in cold, radiation-filled space, and eventually land on a world where chemistry and environment allow them to thrive. The odds may seem slim, Yet the universe is unimaginably vast, and time stretches over billions of years. Even improbable events become inevitable when space and time are infinite. The story of life may be less about randomness and more about the persistence of possibility, patiently unfolding across cosmic scales. Panspermia also reframes our understanding of evolution. On Earth, we often think of life as having a singular terrestrial origin, a beginning in a primordial soup within our oceans. But if life arrived here from elsewhere, then the story of evolution begins not with our planet, but with the universe itself. Our DNA, our biochemistry, may be the continuation of a story that began long before Earth existed, a narrative in which comets and meteoroids are the messengers and planets are the stages where chemistry matures into biology. Life on Earth would then be not an isolated miracle, but a chapter in a much larger cosmic saga. Take a slow, reflective moment and picture the journey of a microscopic organism riding atop a comet. For millions of years, it drifts through darkness, encountering no warmth, no atmosphere, no familiar environment. Yet it endures. Finally, it enters the gravitational embrace of a young planet, crashing through the atmosphere and embedding itself in a primordial ocean. There, the chemistry of the planet embraces it, and the first reactions that may lead to life begin. Across the cosmos, countless similar journeys may occur, most unnoticed, many unsuccessful, but a few achieving the delicate miracle that transforms molecules into biology. This vision also encourages humility. Life in this scenario is not a privilege of Earth or a singular, unique event. It is a phenomenon that the universe may attempt repeatedly across space and time, experimenting with different planets, stars, and galaxies. Earth is remarkable not because it alone harbors life, but because it succeeded in this grand experiment. We are beneficiaries of a cosmic generosity, recipients of seeds that traveled across space and time, arriving on a world capable of nurturing them. The universe is patient, persistent, and remarkably creative, and we are participants in its ongoing experiment. Yet, even as we consider the possibility of life traveling between worlds, a question emerges that has puzzled scientists and philosophers alike. Life is widespread, and the universe distributes its seeds with such abundance, yet we haven't encountered other life forms. This is the paradox that hovers at the edge of panspermia, the tension between the probability of life and the silence we perceive. Perhaps life is abundant but often isolated, confined to nascent planets awaiting favorable conditions. Perhaps advanced civilizations are rare or ephemeral, their signals drowned in the vast expanse of space. Or perhaps we are simply listening in the wrong way, with the wrong instruments, in the wrong moment of cosmic history. The silence does not negate the possibility. It emphasizes the patience of the universe. Life may exist in forms or locations we cannot yet detect. Microbes may flourish in hidden oceans beneath icy shells. Spores may drift silently in interstellar clouds, and nascent biospheres may develop slowly over millions of years. The universe does not hurry, and it does not announce its experiments with fanfare. Panspermia, with its quiet dispersal of life, is consistent with this patient, subtle approach. Life may be everywhere, yet hidden, waiting, quietly unfolding its story across the stars. Consider the philosophical resonance of this idea. If we are all, in some sense, connected to life that originated elsewhere, then the boundaries between worlds blur. The distinction between Earth life and alien life becomes less rigid, and we see ourselves as part of a continuum that stretches across the cosmos. Each living organism, each molecule, each cell carries a story that is simultaneously local and universal. Our existence becomes a bridge between planets, a testament to the resilience and persistence of biology, and a reminder that life is not constrained by geography, time, or human imagination. In this way, the cosmic pollination theory transforms our understanding of home. Home is not only Earth, but the universe itself, a vast network of worlds sharing chemical and biological heritage. Each comet, each asteroid, each speck of cosmic dust becomes a vehicle of connection, linking planets across space in an invisible web of life's potential. In contemplating this, one may feel both humility and wonder, humility at our smallness in the cosmos, and wonder at the extraordinary persistence and creativity of life itself. Take a deep, slow breath and imagine a universe in which life drifts like pollen, subtly, silently, across the stars. Some of it lands and flourishes, some of it fails, But the experiment continues endlessly. Earth, with its oceans, continents, and biosphere, is one of many stages where this cosmic story unfolds. Every living being on this planet may be a participant in an experiment that spans galaxies, a link in a chain of biology that began far beyond our own solar system. The implications are both humbling and beautiful, offering a vision of life as patient, persistent, and profoundly interconnected. And yet, as we admire the elegance of panspermia, the question remains, lingering like a whisper in the cosmic dark. Life is widespread, yet we haven't heard from anyone else. The universe may be generous with chemistry and potential, but the emergence of intelligence, communication, and detectable civilizations may be rare, subtle, or delayed by the vastness of space. The silence challenges us to look deeper, to consider time as well as space, to explore not only where life could exist, but why it may be quiet, hidden, or incomprehensible from our perspective. For all the evidence that the universe is brimming with the ingredients of life, for all the discoveries of molecules, comets, and habitable planets, there remains a profound, unsettling truth. The cosmos is, so far, silent. We look to the stars, imagining other worlds teeming with life, and yet, in return, we hear nothing. This is the essence of the Fermi paradox, a puzzle that has haunted astronomers, philosophers, and dreamers alike. If life is common, if biology is a universal phenomenon, then where is everyone? Why has no civilization reached out? Why have no signals pierced the vast darkness of space to announce their existence? The paradox begins with probability. Across billions of stars in our galaxy alone, each hosting planets, some within the habitable zone, it seems almost inevitable that life should emerge elsewhere. If amino acids form naturally in nebulae, if planets provide cradles for chemistry, if comets can distribute molecules across interstellar space, then the seeds of life are abundant. Yet, despite the potential for countless planets to host biology, our instruments have detected no definitive signs of intelligent life. The universe, fertile as it seems, remains eerily quiet. One possible explanation is time. Civilizations may have risen and fallen long before humans appeared, their signals fading into the void, undetectable after millions of years. Humanity exists in a brief window of cosmic history, a fleeting moment in which we can observe, wonder, and ask questions. Perhaps other civilizations were like ours, ephemeral sparks of life that flickered and vanished, leaving only chemical traces or artifacts buried in the rubble of distant worlds. The silence we perceive is not evidence of absence, but a reflection of our temporal isolation, a reminder that the cosmos operates on scales far beyond human lifetimes. Another possibility is rarity. Life, while chemically plausible, may be extraordinarily fragile. The emergence of complex, intelligent beings might require a precise confluence of conditions: stable planetary environments, protective atmospheres, and favorable evolutionary pathways. Many worlds may harbor simple life, microbes in oceans or beneath ice, but intelligence, the ability to communicate across light years, may be exceptionally rare. In this scenario, the universe is abundant in biology, but sparse in civilizations capable of sending messages, leaving us as perhaps one of the few observers capable of contemplating our place in the cosmos. The silence also forces reflection on fragility. Civilization, even intelligent life, may be transient. Technological species may self-destruct, fall victim to environmental collapse, or succumb to cosmic hazards such as supernovae, gamma-ray bursts, or asteroid impacts. Earth itself is not immune. Humanity exists in a delicate balance, a brief flourish of intelligence atop a fragile ecosystem. The Fermi paradox, in this light, becomes a meditation on caution, a subtle warning that life, once awakened, is precious and vulnerable. Our responsibility extends beyond mere survival. It encompasses stewardship, preservation, and mindfulness of the fragile spark we represent in a quiet universe. Yet silence is not absence. The universe may be rich with life that we simply do not perceive. Perhaps signals are too faint, too subtle, or transmitted in ways we cannot detect. Perhaps advanced civilizations use communication methods beyond our understanding, or their lifetimes are so brief that the likelihood of overlapping with ours is vanishingly small. Our search is limited by both technology and perspective. We scan radio frequencies, visible light, and the occasional chemical signature, but the cosmos may whisper in languages we have yet to learn. Silence, then, is a reminder that our methods are imperfect and our understanding incomplete. Consider the metaphor of a darkened theater. You stand in the back, waiting for a performance, straining to hear. The stage is vast, the actors may be present, yet the curtains remain drawn, the lights dimmed, and the voices faint. You do not hear the performance, but that does not mean it is not occurring. Perhaps the timing is off, or the medium obscures your perception. Similarly, the universe may host life and intelligence, yet its signals are hidden, subtle, or delayed by the vast distances and scales of time. Our silence is not final. It is an invitation to refine our senses, expand our understanding, and imagine possibilities beyond immediate detection. The Fermi paradox also has philosophical resonance. It compels us to consider our uniqueness and the weight of our responsibility. If intelligent life is rare, if civilizations are transient, then humanity may be among the few conscious observers capable of witnessing and reflecting on the cosmos. We are not merely participants in life's grand experiment. We may also be stewards of it, tasked with preserving the fragile flame of awareness amidst the vast darkness. Every choice, every act of environmental care or destruction reverberates with significance on a scale far larger than our immediate surroundings. This silence invites humility as well as wonder. The universe is vast, old, and patient. Billions of years have passed while galaxies formed, stars ignited, and planets coalesced. Life, if it emerges at all, unfolds on timescales that dwarf human history. To be a conscious observer, aware of the paradox and capable of inquiry, is extraordinary. We inhabit a rare window in which reflection is possible, and the silence that surrounds us magnifies the value of our curiosity, our imagination, and our capacity for wonder. And yet, there is comfort in the paradox. Silence is not defeat. It is a challenge, a question posed to humanity, to look deeper, think harder, and seek more patiently. It reminds us that the universe is not obliged to reveal itself on demand. It asks for humility, persistence, and imagination. Our search for extraterrestrial life is therefore not simply a quest for neighbors. It is a meditation on existence, a contemplation of time, and a test of our capacity to wonder at scales that surpass comprehension. Take a quiet moment to imagine the possibilities. Somewhere in a distant galaxy, life may be stirring beneath an alien ocean, evolving over eons. In another, civilizations may have risen and fallen, leaving chemical traces or artifacts we cannot detect. Perhaps intelligent life exists, but its signals travel in forms incomprehensible to our technology. The universe is vast and patient, indifferent yet full of potential. Silence is not absence. It is subtle, a gentle reminder of the patience and scale of cosmic evolution. The great silence also prompts reflection on our own fragility and responsibility. If life is rare, if intelligent civilizations are fleeting, then our actions on Earth gain extraordinary significance. Every effort to preserve ecosystems, to understand our biosphere, to cultivate knowledge becomes an act of cosmic importance. We are the stewards of a rare window of awareness, the caretakers of a small planet in a universe that may otherwise remain unaware. The paradox becomes a meditation on humility, ethics, and the delicate wonder of existence. And still, silence should not be mistaken for emptiness. It is possible that we simply have been looking in the wrong way. Perhaps the signals of life are subtle, chemical, or buried in forms we cannot yet recognize. Perhaps the universe communicates on scales or in media beyond our current technology, or life exists in states that defy conventional biology. The absence of evidence is not evidence of absence. Like a detective following faint clues across a vast crime scene, we may yet uncover signs of life in ways we have not imagined. As we sit beneath the stars, contemplating the vast darkness and the great silence, we are invited into a deeper awareness. The universe is older and larger than we can fully grasp, and life, if it exists elsewhere, may follow rhythms and timelines beyond our comprehension. Yet, the very act of searching, of questioning, of imagining, connects us to that larger story. The silence becomes a canvas on which we project our curiosity, patience, and wonder. A space in which possibilities unfold gently, quietly, across eons. Take a slow, reflective breath and let the vastness of the cosmos wash over you. The universe is silent, yet not empty. It is rich with potential, with history, and with possibilities for life that stretch beyond our imagination. The absence of voices does not negate existence. It invites exploration, reflection, and humility. In this silence, we sense the fragility of our own existence, the weight of our responsibility, and the extraordinary gift of consciousness that allows us to ask these questions. And so we continue, aware of the quiet, patient universe surrounding us, knowing that our search is far from over. There is much yet to see, much yet to understand, and countless possibilities to imagine. Silence does not imply emptiness. It is subtle, mysterious, and inviting, a gentle nudge toward patience, curiosity, and careful observation. Perhaps in time, and with continued exploration, the whispers of life across the cosmos will become clearer, guiding us to new understanding and deepening our connection to the universe. For centuries, humanity has gazed at the stars in wonder, imagining distant worlds, unknown civilizations, and the possibility that life exists beyond our fragile blue planet. We have observed their light, measured their motions, and traced their paths across the sky. Yet in recent decades, our approach has become more sophisticated. NASA and astronomers around the world have realized that it is not enough to simply look at distant planets or catalog their chemical composition. To truly understand the cosmos and our place within it, we must also listen. Listening, in this sense, is not merely auditory. It is a careful observation of signals, a study of subtle distortions in starlight, and a decoding of faint radio waves that traverse the vast emptiness of space. When a planet passes in front of its star, it casts a shadow that alters the starlight we receive. By analyzing these tiny fluctuations, astronomers can infer the presence of an atmosphere, the composition of gases, and even hints of surface conditions. A slight wobble in a star's motion can indicate an orbiting planet. And amidst these subtle cosmic signals, there may be anomalies, patterns, repetitions, or emissions that cannot be easily explained by natural processes. Such anomalies could, in principle, hint at intelligence, technology, or organized activity beyond our world. Imagine the scene: a distant star, so far away that its light has taken hundreds or even thousands of years to reach us, flickers ever so slightly. Embedded in that flicker is a story, a message carried across the void. It could be a planet with an atmosphere conducive to life, a chemical signature of biology, or even perhaps evidence of civilization. Astronomers devote years, even decades, to collecting data from such stars, sifting through the subtle variations in light, listening to the whispers of the universe. Each observation is meticulous, patient, and demanding, yet each holds the potential to transform our understanding of reality. Radio waves offer another dimension of listening. For nearly a century, humans have transmitted radio signals into space, unintentionally announcing our presence to any civilizations capable of detecting them. In turn, we have trained sensitive instruments to monitor the heavens, searching for signals that may not be naturally occurring, for patterns that suggest intelligence. A regular pulse, a repeated sequence, or a signal concentrated in a narrow frequency band could indicate something deliberately sent. Even a single confirmed anomaly would reverberate through human thought, rewriting our perception of the cosmos and our place within it. The act of listening to starlight, to radio waves, and to cosmic signals carries a profound emotional weight. It is a reminder of our smallness, of how minute and fragile our planet is compared to the vastness of the universe. And yet, it is equally a testament to our curiosity, our relentless desire to reach beyond our immediate surroundings, to seek understanding, and to know whether we are alone. The very effort of tuning into the universe, of dedicating time, intellect, and technology to detect whispers across light years, reflects a deep human need to connect, to understand, and to belong. Consider the subtlety of these signals. A tiny fluctuation in a star's brightness may hint at an exoplanet orbiting hundreds of light years away. Yet our instruments must distinguish it from cosmic noise, from pulsations of the star itself, from interstellar dust that scatters light unpredictably. Each observation requires careful calibration, repeated measurements, and patience that stretches over years. The data is vast, and patterns can be elusive. Yet within this careful listening lies the potential for discovery, a promise that even the smallest anomaly could carry profound significance. Listening also reminds us that the universe communicates in ways that are patient and subtle. It does not rush, it does not announce itself with spectacle. The light from distant stars has traversed eons to reach our telescopes. The faint radio waves may have begun their journey long before humans ever existed. The cosmos operates on timescales and distances that dwarf our perception. And yet, by tuning our instruments and refining our understanding, we can perceive these messages. In doing so, we participate in an extraordinary dialogue with the universe, one that requires patience, imagination, and humility. The profoundness of this act becomes even clearer when we reflect on the potential consequences of a detection. Imagine receiving a signal from a distant star system that cannot be explained by natural phenomena. Even a single confirmed anomaly would revolutionize science, philosophy, and human self-perception. It would confirm that intelligence is not unique to Earth, that we are part of a larger community of conscious beings, however distant they may be. The ramifications would ripple through culture, religion, and thought, expanding our sense of belonging from our small planet to the cosmos itself. Yet, even as we contemplate such discoveries, the universe teaches patience. The silence we perceive is not necessarily emptiness. Perhaps civilizations are quiet, deliberately so, or perhaps their technology is beyond our capacity to detect. Perhaps life exists in forms we cannot recognize, communicating through mediums we have yet to invent. Our listening is limited by both perception and imagination. The absence of obvious signals is not a verdict of absence, but an invitation to refine our methods, to expand our understanding, and to remain attentive to the subtle whispers that might otherwise go unnoticed. Listening to the cosmos also invites reflection on the nature of knowledge itself. The universe speaks in subtle signs: the bending of light by gravity, the spectral signatures of molecules, the timing of pulsars, and the faint echoes of radiation from the earliest stars. By learning to interpret these signs, we expand our perception, connecting our experience to the grand scales of space and time. We realize that intelligence is not simply a matter of technological achievement, but of awareness, interpretation, and patience. To hear the universe requires tuning not only instruments, but minds and hearts, cultivating a sensitivity to signals both faint and profound. Take a slow, meditative moment and imagine the process of listening. You are suspended in silence, staring into the void, attending to the faintest variations in starlight. A single anomaly appears, a pattern you cannot immediately explain. It could be a planet with an atmosphere capable of supporting life, a chemical signature that hints at biology, or, in a dream of imagination, evidence of a distant civilization. For a brief instant, the universe feels intimate, its vastness softened by the connection created through observation. Even if nothing further is discovered, the act of listening itself becomes an affirmation of curiosity, wonder, and hope. The beauty of this approach lies not only in potential discovery, but in the act itself. Humanity, so small in the grand cosmic scale, stretches across unimaginable distances with instruments and imagination. We are listening, patiently and attentively, for signals that may arrive millennia after they were sent. This quiet effort connects us to the universe in a profound way, reminding us that our consciousness is part of a larger story, one that spans space, time, and possibility. The act of listening becomes meditative, a way of participating in the cosmos with humility, curiosity, and reverence. And yet, the meaning we attach to life beyond Earth is as mysterious as the signals we seek. Listening is not only about detection or proof, it is also about imagination, about expanding our sense of what is possible, and contemplating the profound question of existence. Whether we hear a whisper or remain in silence, the act itself nurtures a sense of connection, wonder, and reflection. In tuning into the universe, we reflect upon ourselves, our curiosity, and our place within a vast, patient, and intricate cosmos. As we continue this cosmic listening, we are reminded that every faint signal is a reminder of our smallness and our persistence. Each photon from a distant star, each radio wave traversing light years, carries a potential story. It is up to us to pay attention, to decode, and to imagine. Silence is not a void. It is a space for discovery, contemplation, and humility. It teaches us patience, invites reflection, and inspires hope. And so, in the quiet of our observations, as instruments hum softly and telescopes track distant stars, we participate in a conversation with the cosmos that has been ongoing for billions of years. The universe is patient, subtle, and immense. We listen not only for proof of life elsewhere, but for the beauty of connection, for the affirmation that curiosity itself is a bridge between worlds. In this gentle, attentive listening, we discover not only the universe, but ourselves. Every quest for alien life is, in a profound sense, a quest for understanding ourselves. When we look outward into the cosmos, searching for hints of life beyond our planet, we are also peering inward, reflecting on what it means to be human. Each telescope, each radio dish, each spectral analysis is not merely a technical endeavor. It is a mirror reflecting our own curiosity, our own longing, and the deep-seated desire to find connection in a universe that feels immense and impersonal. The question, "Are we alone?" is deceptively simple. Spoken aloud, it evokes visions of distant civilizations, planets bathed in alien sunlight, and worlds that might host life unimaginable to our senses. Yet hidden within the question is another. Who are we? If life exists elsewhere, how would it change our understanding of ourselves? Our philosophies, our religions, our stories, and even our sense of purpose are shaped by the assumption that humanity is unique, or at least exceptional. The discovery of life beyond Earth would ripple through every aspect of our self-conception, forcing us to confront both our insignificance and our connectedness to the cosmos. Consider the longing implicit in this search. Humanity has always yearned to connect with the unknown, to reach beyond our immediate surroundings, to transcend the boundaries of our own planet. When astronomers tune into faint signals from distant stars, when missions probe the atmospheres of exoplanets, when scientists study the chemical fingerprints of distant nebulae, they are participating in an ancient human impulse: to listen, to observe, and to hope for confirmation that we are not alone. This hope is not merely scientific, it is deeply emotional. It speaks to our desire for companionship, for affirmation that the universe is not indifferent, and that life, our own or another's, is a shared phenomenon rather than a singular anomaly. The search for extraterrestrial life is also a reflection of our narrative instincts. Humans are storytelling creatures, and the cosmos is the ultimate canvas for our imagination. Every discovery, every chemical signature, every distant exoplanet becomes a character in a story we are compelled to tell. When we ask whether life exists beyond our galaxy, we are, in effect, writing ourselves into a larger narrative. The possibility of alien life challenges our imagination, inviting us to construct worlds, civilizations, and experiences that end beyond the confines of Earth. In doing so, we explore the boundaries of empathy, curiosity, and creativity. At the same time, the act of searching illuminates our own fragility and resilience. We are acutely aware of the rarity and delicacy of life on Earth. Our biosphere, balanced across oceans, continents, and atmosphere, is finely tuned to sustain the web of life. The potential discovery of life elsewhere magnifies our appreciation for this intricate balance, reminding us that life is both tenacious and fragile. The mirror of discovery reflects not only our hopes, but our responsibilities to cherish, protect, and nurture the singular example of life that we know intimately. Philosophically, the search for life beyond our galaxy opens doors to profound introspection. What does it mean to be conscious, to be intelligent, to perceive, to wonder, to question? If life emerges elsewhere, perhaps even intelligence, then our understanding of morality, ethics, and existence is no longer confined to human experience alone. We begin to consider the universality of life's principles, the potential commonalities between Earth biology and alien forms, and the shared imperatives that may govern existence across the stars. Our search becomes both a scientific endeavor and a meditation on the essence of being. There is also a quiet humility inherent in this journey. Humanity is small, fragile, and young in the context of cosmic time. Stars have been forming and dying for billions of years before our species appeared. Galaxies have evolved, collided, and dispersed across the void long before humans first walked the Earth. To search for life beyond our galaxy is to confront our own fleeting existence, to recognize that we are temporary participants in a vast, ongoing experiment of creation. And yet, in the act of searching, we assert our curiosity, our capacity for wonder, and our desire to understand, demonstrating that even a brief spark of consciousness can reach across unimaginable distances to seek meaning. Our curiosity also reveals something deeply social. The question of alien life is intertwined with our longing for connection. We seek others, whether microscopic organisms or intelligent civilizations, because we recognize on some level that connection validates existence. It reassures us that life is not an accident, that consciousness is not an isolated phenomenon, and that the universe, vast and often indifferent, is nonetheless capable of harboring experience, awareness, and imagination. When astronomers scan starlight for anomalies or search for biosignatures in exoplanet atmospheres, they are engaging in an act of hope, a projection of our desire for companionship across cosmic scales. And yet, there is subtlety in this mirror. The search for life beyond our galaxy may ultimately reveal less about other civilizations and more about ourselves. How we interpret signals, how we imagine life forms, and how we construct scenarios in our minds are deeply human processes. The stories we tell about alien life often reflect our values, fears, and aspirations. In imagining distant worlds, we project our curiosity, creativity, and ethical frameworks onto the cosmos. Even silence, the absence of detectable life, speaks volumes about human perception and expectation, shaping the narratives we construct about the universe and our place within it. The mirror of discovery also teaches patience and humility. Cosmic distances are immense, and even light takes millions of years to traverse the space between galaxies. The processes that give rise to life unfold on geological and astronomical timescales, far longer than a human lifespan. The act of searching, therefore, requires a surrender to scale, a recognition that understanding may come slowly, fragment by fragment, across generations. In this patience, we learn not only about the cosmos, but about the rhythms and persistence of curiosity itself. Take a moment to reflect on this. Each exoplanet we discover, each spectral signature we analyze, each chemical trace we detect in a distant nebula is not only evidence of possibility, it is also a reflection of our own desire to understand, to find meaning, and to connect. Humanity reaches outward and simultaneously inward, tracing threads of identity and belonging across the stars. In seeking life elsewhere, we confront the question of who we are, what we value, and how we situate ourselves within the vast, patient architecture of the universe. The search for life beyond our galaxy also reminds us that wonder is a universal human trait. It transcends culture, language, and geography. Whether through ancient stargazing, modern telescopes, or interstellar probes, the desire to know, to see, to imagine persists. The mirror of discovery reflects the constancy of this impulse, showing that even in the face of silence, uncertainty, and incomprehensible scales, curiosity endures. It is a reminder that our search is as much about the journey as it is about the destination, that the act of asking, imagining, and reflecting is itself a form of participation in the universe's story. And in this reflective act, the potential discovery of life becomes a meditation. We contemplate not only the mechanics of biology or chemistry, but the deeper meaning of existence. What does it mean to be alive? What does it mean to wonder, to question, to reach beyond ourselves? The possibility of life beyond our galaxy is not merely a scientific question. It is an invitation to explore the nature of consciousness, connection, and meaning. It asks us to consider whether our own stories, our own creativity, and our own curiosity are threads in a tapestry that stretches across space and time. Even in silence, the universe mirrors our longing. Every faint signal, every potential biosignature, every meteorite carrying amino acids is a subtle reflection of our desire to understand. The cosmos becomes a canvas not only for discovery, but for imagination, reflection, and philosophical inquiry. By searching for life beyond Earth, we are participating in a conversation that spans billions of years and light years, engaging in a dialogue with the cosmos itself about the nature of life, awareness, and existence. And so, the mirror of discovery reveals a profound truth. The search for life beyond our galaxy may be less about them and more about us. It is a meditation on curiosity, creativity, and connection. It is a story about how we imagine ourselves in relation to the vast, patient universe. The act of searching, reflecting, and listening teaches us humility, patience, and wonder. It reminds us that even in our smallness, we are capable of reaching across unimaginable distances to ask the deepest questions, to dream, and to hope. As we contemplate distant worlds, alien chemistry, and the subtle possibilities of life beyond, we realize that the cosmos is both a laboratory and a mirror. It reflects our curiosity, our longing, and our capacity for imagination. Every discovery, every hypothesis, and even every unanswered question is a reflection of the human desire to connect, to understand, and to belong. The universe does not merely exist, it responds to our attention, our reflection, and our imagination, offering a patient, quiet dialogue for those willing to observe and wonder. And so we continue, carrying both hope and humility, curiosity and reflection across the vast spaces of imagination and inquiry. Life beyond our galaxy, if it exists, may teach us more about ourselves than we could have ever anticipated. In searching the cosmos, we search our own identity, our stories, and our place in the grand unfolding narrative of existence. Long before the first telescopes pierced the night sky, humans gazed upward, weaving stories from the points of light scattered across the darkness. Constellations were drawn not merely to map the heavens, but to make sense of our place within them. The myths of countless civilizations, from the Babylonians and Egyptians to the Greeks, Mayans, and Chinese, spoke of gods, spirits, and beings that descended from the stars, shaping life and influencing the destinies of humankind. These ancient narratives were early attempts to grasp the cosmos, to connect the human experience to the vast, unknowable expanse overhead. In many myths, the stars were not passive. They were active participants in life's story. Gods fell from the sky to teach knowledge, to bring fire, or to seed life in ways that mirrored the modern scientific concept of panspermia. In the sky itself, humans saw a reflection of their hopes and fears, projecting meaning onto the unchanging lights above. A shooting star became a messenger, a comet a herald of change, and the Milky Way itself a river along which spirits traveled. These stories, rich with metaphor and imagination, were humanity's first explorations into the possibility that life and intelligence might exist beyond Earth, a yearning expressed in the language of myth rather than data. As centuries passed, our methods evolved. We developed instruments to measure light, to calculate planetary motions, and to detect the invisible forces shaping the cosmos. Where once imagination provided answers, now science began to provide explanations. Yet even as telescopes and spectrometers replaced myths, the emotional resonance remained. The same wonder that inspired our ancestors to tell stories of gods and celestial travelers now drives scientists to scan distant stars for planets, to detect the faint chemical signatures of life, and to ask whether intelligence might exist elsewhere. The tools have changed, but the human impulse is constant, to look outward and dream, to search for meaning in the vastness of space. Consider the modern equivalent of these ancient myths. Reports of unidentified flying objects, accounts of strange lights in the sky, and imaginative depictions of alien worlds continue to capture our collective imagination. Today, some of these stories are met with skepticism, others with fascination, but they all echo the same deep curiosity that motivated our ancestors. The unknown, whether framed as divine or extraterrestrial, evokes wonder. It sparks inquiry, reflection, and often a quiet meditative fascination with the possibilities that lie beyond our perception. Humans have always been storytellers, and the cosmos remains the grandest canvas on which we project our narratives. In the modern era, NASA and other space agencies have transformed myth into measurable inquiry. Telescopes like Kepler, Hubble, and JWST allow scientists to peer into distant galaxies, detecting exoplanets, tracing atmospheres, and searching for the chemical fingerprints of life. Every photon of light captured, every spectrograph analyzed, turns the poetic curiosity of myth into quantitative investigation. Comets, asteroids, and nebulae, once the inspiration for divine tales, are now subjects of careful study, revealing the chemical ingredients that make life possible. In a sense, science has taken the place of gods and spirits, providing explanations that satisfy curiosity while leaving room for awe. Yet, despite this transition, the wonder of myth persists. Science does not diminish imagination, it channels it. While telescopes measure the composition of exoplanet atmospheres or detect the subtle wobbles of stars, the human mind continues to wonder about civilizations, ecosystems, and histories that may exist light years away. Even the most rigorous scientific discovery carries a poetic echo, the recognition that life, consciousness, and intelligence may not be unique to Earth. In this, myth and science converge, meeting at the horizon of the unknown, each shaping the way we perceive possibility and each enriching the other. Ancient myths also remind us that curiosity is intertwined with meaning. Stories provided a framework to interpret phenomena that were otherwise mysterious or overwhelming. A comet might portend a ruler's fall, a solar eclipse might signal divine displeasure, and the nightly stars map destinies and moral lessons. Similarly, modern science offers frameworks for understanding, but it also provides stories of its own, narratives of discovery, of planets forming from cosmic dust, of chemical reactions unfolding in distant nebulae, and of the potential universality of life. In both cases, humans seek coherence, a way to place themselves within the grand, unfolding narrative of the universe. There is also a continuity across time that is profound. The same night sky that inspired mythologists and early astronomers continues to inspire modern scientists. The constellations have shifted little. The Milky Way still stretches across the heavens, and the cycle of stars being born and dying continues unabated. Our ancestors may have interpreted these lights as signs from gods, while today we interpret them as data points. Yet both perspectives are attempts to reconcile human experience with the vast, indifferent cosmos. Myth and science are two languages describing the same reality, a universe immense, beautiful, and full of possibilities. The interplay of myth and science also shapes how we approach the unknown. Myth encourages imagination, allowing us to envision life forms, civilizations, and cosmic events beyond our direct perception. Science provides the tools to test these ideas, to confirm or refute possibilities, and to ground imagination in evidence. In combination, they create a rich cognitive landscape, one where curiosity is nurtured by wonder and guided by method. Without myth, science might lose its poetry. Without science, myth might remain untethered from reality. Together, they form a continuum, leading humanity ever closer to understanding, yet never fully extinguishing the mystery that drives us forward. Take a quiet moment to reflect on this continuum. Picture an ancient storyteller pointing to the sky, explaining the movements of stars as messages from distant gods. Then imagine a modern scientist, eyes fixed on a telescope, half decoding the light of a faraway exoplanet, searching for oxygen, methane, or other signs of life. The impulse is the same, to reach out into the darkness, to find connection, and to interpret meaning from phenomena that are immense, distant, and often subtle. In both cases, wonder and curiosity bridge the gap between human perception and the cosmos, linking our imagination with observation, myth with measurement. The meeting of myth and science also influences how we imagine life beyond Earth. When we envision extraterrestrial beings, we often draw from familiar forms, humanoid, insect-like, or microbial, while also allowing imagination to stretch beyond terrestrial constraints. Science provides limits and possibilities. The presence of liquid water, the chemical composition of atmospheres, the intensity of stellar radiation. Myth encourages us to explore the unconstrained, to imagine life that might be unrecognizable, yet real within its own environment. Together, they expand both our expectations and our capacity for wonder. Ultimately, the horizon where myth meets science is the horizon of the unknown. It is the space where humans confront the possibility of life beyond our galaxy, and in doing so, confront themselves. We wonder about life elsewhere, not simply to catalog biology, but to explore questions of meaning, identity, and connection. Each comet studied, each exoplanet characterized, each faint spectral signature analyzed is part of a long tradition of human engagement with the cosmos, a tradition that stretches from ancient stories to modern science, from imagination to data, from myth to measurement. And just as myths gave meaning to the stars, science now gives us tools to peer deeper, to see further, and to ask questions that would have been unimaginable to our ancestors. Yet the wonder remains, unchanged across millennia. The stars invite us to look up, to dream, and to imagine what else might exist. Science measures, myths inspire, and together they illuminate a single truth. The universe is vast, mysterious, and endlessly compelling. Our stories, whether poetic or analytical, are the bridge that allows us to reach across light years, across time, and into the heart of possibility itself. In the quiet moments of reflection, we can appreciate this continuum. Our ancestors' myths remind us that humans have always reached for the unknown, while our modern instruments remind us that the unknown is not unreachable. Each discovery, each hypothesis, each data point becomes a continuation of the same human narrative, a narrative of curiosity, imagination, and the desire to connect. Myth and science, far from being opposed, form a duet that carries us forward, guiding our gaze and our mind toward horizons that are simultaneously tangible and fantastical. And so, as we continue to explore the universe, as telescopes and probes reach further into the cosmic night, we carry with us both the stories of our ancestors and the methods of our science. In the interplay between myth and observation, imagination and measurement, we discover not only the universe, but the enduring human impulse to wonder, to explore, and to seek connection in the vast, patient expanse of the cosmos. As humanity peers deeper into the cosmos, the line between the possible and the extraordinary begins to blur. The Milky Way, once our reference frame for imagining distant life, is now just a single island in a vast cosmic ocean. Beyond it, countless galaxies stretch across the universe, each containing billions of stars, each potentially hosting planets, and, perhaps, the chemistry of life. NASA's latest observations have begun to hint at something astonishing. The ingredients for life may not be confined to our galaxy, or even to galaxies nearby. They may be woven into the fabric of the universe itself, scattered across billions of light years, present since the cosmos was young. The James Webb Space Telescope, with its unprecedented sensitivity to infrared light, has opened a new window into these ancient realms. JWST can detect the faint glow of distant galaxies whose light has traveled for billions of years, reaching us from an era when the universe was a fraction of its current age. And in the light of these distant galaxies, astronomers have found something remarkable: complex molecules, some resembling the very precursors of RNA, the fundamental script of life. These molecules are not simple atoms floating in isolation. They are organized, structured, and capable of participating in chemistry that, on Earth, leads to biology. It is as if the universe itself, in its earliest epochs, began to prepare the stage for life. Imagine for a moment the vastness of this possibility. Billions of years before our planet even formed, galaxies far away were already rich with the building blocks of life. Stars ignited, planets coalesced, and chemical reactions unfolded in ways that, on Earth, would eventually give rise to DNA, RNA, and proteins. This implies a profound temporal depth to life's potential. Life, or at least the potential for it, is not a latecomer to the universe. It may have been present from the cosmic dawn, scattered across galaxies as atoms, molecules, and dust. In a very real sense, the universe may have been preparing for life long before humans ever appeared. The implications are staggering. If the precursors of life exist in galaxies billions of light years away, then the potential for biology is not restricted by distance or by the confines of our own solar neighborhood. The chemistry of life could be as universal as the laws of physics themselves. It invites us to imagine a cosmos where life is not an anomaly, but a natural consequence of matter and energy interacting over billions of years. Life might be widespread, hidden in the clouds of distant exoplanets, in the icy moons of alien systems, or in the molecular clouds that drift between stars and galaxies. Each of these environments may be a cradle, waiting patiently for chemistry to blossom into biology. Consider the poetic resonance of such a possibility. Every breath we take, every molecule in our bodies, contains atoms that were forged in stars long dead, scattered across space, and eventually assembled into the matter that makes life possible. If complex molecules exist far beyond our galaxy, then perhaps life elsewhere shares this same intimate connection to the cosmos. The universe is not a cold void, but a living workshop, where chemistry unfolds patiently, persistently, and on scales that are almost incomprehensible. The story of life becomes a story of the universe itself, a narrative that stretches across billions of light years and billions of years of cosmic history. This vision also challenges our sense of temporality. Life on Earth, so young in comparison to the cosmos, may be part of a much larger, older tapestry. Civilizations may have arisen and fallen in distant galaxies long before the first humans walked the Earth. Planets may harbor ecosystems older than our own, with life forms that evolved along trajectories we cannot imagine. The universe, it seems, may host a continuity of life that transcends time and space, a subtle, patient unfolding that began not with us, but with the first chemical reactions in the earliest galaxies. The discovery of complex molecules in these distant galaxies also underscores the universality of chemistry. The same elements that form the backbone of life on Earth, carbon, Hydrogen, nitrogen, oxygen, phosphorus, and sulfur are abundant throughout the cosmos. These elements combine in similar ways, producing amino acids, sugars, and nucleobase precursors, regardless of location. This universality suggests that the principles guiding chemistry are consistent across the universe, that life is not a local accident, but a possible outcome of the natural order. In this sense, the universe itself may be predisposed to life, a vast laboratory where the conditions for biology are not rare, but widespread. And yet, the vast distances involved temper our perspective. Even if life exists in galaxies billions of light years away, the sheer scale of space and time makes direct interaction improbable. Signals, travel, and influence are limited by the speed of light. Civilizations may exist in parallel to our own, unaware of each other, separated not by hostility, but by the immensity of the cosmos itself. In contemplating life beyond galaxies, we are confronted with both exhilaration and humility. Exhilaration at the vast possibilities, and humility at our own small, localized perspective, within a universe that is almost incomprehensibly vast. This cosmic perspective reshapes how we think about life and existence. Life becomes less a local phenomenon, confined to a single planet, and more a fundamental expression of the universe's chemistry and physics. It is a phenomenon that could, in principle, emerge wherever conditions allow, wherever chemistry unfolds in a dance of energy, time, and matter. We begin to see life as a universal symphony, composed not only on Earth, but throughout the cosmos, in a variety of forms, ages, and stages of complexity. In this symphony, we are one instrument among billions, participating in a harmony that has been playing since the universe was young. The philosophical implications are equally profound. If life's building blocks existed when the universe was young, then life itself may be as old as time, as vast as space. Humanity's story is just one verse in a cosmic poem, a fleeting expression of a much larger, ongoing process. The search for extraterrestrial life, then, becomes an exploration of continuity, how chemistry leads to biology, how galaxies nurture potential, and how intelligence, if it arises, participates in a universe that has been patiently preparing for it across eons. It challenges anthropocentric notions, reminding us that life and consciousness may be far more widespread and persistent than we have imagined. Take a moment to reflect on this. Imagine the first galaxies forming, clouds of gas coalescing into stars, chemical reactions unfolding in the icy reaches between them, molecules combining and recombining in ways that eventually set the stage for life. Across billions of light years, this same process could have repeated countless times. We are connected, at a fundamental level, to this ancient, universal chemistry. The atoms in our bodies, the molecules that constitute life on Earth, may share ancestry with molecules formed in galaxies that will never be seen by human eyes. In this realization, the universe feels intimate, interconnected, and alive with possibility. NASA's discoveries, then, are not just about distant galaxies or exotic chemistry. They are about perspective. They teach us patience, inviting us to expand our sense of scale, time, and possibility. They invite us to consider life as a cosmic phenomenon, not merely an earthly one. They ask us to imagine civilizations, ecosystems, and forms of life that may exist in parallel to our own, unfolding across a universe that is far older, larger, and stranger than our immediate perception allows. In this view, life is a continuum, a natural consequence of the universe's structure, patiently waiting for chemistry, time, and opportunity to converge. And yet, the grandest question remains: what does this mean for us, here and now? If life is potentially so vast, so ancient, and so widespread, humanity must consider how to respond. We must reconcile our sense of uniqueness with the possibility that we are one of countless examples of conscious living matter scattered across the cosmos. This understanding reshapes our ethics, our ambitions, our stewardship of life on Earth, and our place in the unfolding story of the universe. These reflections linger, gentle yet persistent, reminding us that the search for life beyond galaxies is not only about distant stars, it is also about ourselves and the choices we make as temporary custodians of life on our small, fragile planet. In contemplating life beyond galaxies, we are invited into a quiet, reflective space, a meditative recognition of the vastness of time, the universality of chemistry, and the subtle possibility of life across the cosmos. The discoveries of NASA, the observations of JWST, and the faint chemical signatures of distant galaxies are all threads in a tapestry that connects the distant past to the present moment, the unseen universe to the awareness of human consciousness. They ask us to imagine life not as rare, isolated, or exceptional, but as a cosmic phenomenon embedded in the very fabric of reality. And so, as we continue to scan the heavens, as instruments capture photons that have traveled billions of years, we carry a sense of wonder, humility, and possibility. The universe is not only ancient and vast, but alive with potential, rich with chemistry, and patient in its unfolding. Life, wherever it exists, is part of a grand, ongoing process, a phenomenon that stretches across galaxies, time, and imagination. In this realization, we glimpse a cosmos that is intimate, connected, and profoundly inspiring. There is a quiet, almost meditative transformation that occurs when we look outward into the cosmos and allow ourselves to contemplate the possibility that life may exist beyond our galaxy. To consider that distant galaxies, billions of light years away, might harbor the chemical precursors, the molecules, or even forms of life itself, is to confront a perspective that is simultaneously humbling and exhilarating. The act of looking outward does more than teach us about distant stars and planets. It teaches us about ourselves. When we gaze at the night sky and imagine the billions of galaxies stretching across the universe, each a potential cradle for life, we begin to see our own story differently. Humanity is no longer a lone flame flickering in an infinite void. We are part of something much larger, part of a cosmic pattern that has been unfolding for billions of years. The atoms in our bodies, once forged in ancient stars, connect us to the same chemistry that may have given rise to life in distant galaxies. Our existence is intertwined with the universe in ways that are both intimate and staggering. This perspective reshapes our sense of identity. On Earth, human life often feels isolated, ephemeral, and fragile. We perceive ourselves as singular, unique, and distinct from the vast, impersonal universe around us. Yet when we consider that the building blocks of life may be universal, scattered across countless galaxies, our narrative shifts. We are no longer merely isolated beings on a small planet. We are participants in a grand cosmic process. Our existence is a note in a symphony that began long before our species appeared, a melody that may resonate elsewhere in the universe in forms we cannot yet imagine. There is profound humility in this realization. When viewed from a cosmic scale, human conflicts, anxieties, and preoccupations shrink into perspective. The vastness of space, the immensity of time, and the universality of chemistry remind us of the fleeting nature of our existence. Yet within that humility lies a quiet comfort. Our smallness is not insignificance. Instead, it is a recognition that we are part of something unimaginably vast, that our lives are threads in a tapestry woven from the same elements that have shaped galaxies, stars, planets, and perhaps even life itself across the universe. The cosmic perspective also nurtures a sense of awe. To think that galaxies far beyond our Milky Way could contain the same molecules that eventually formed life on Earth is to witness a continuity that transcends distance and time. It invites reflection on the interconnectedness of all things: the stars, the atoms, the chemistry, and the consciousness that contemplates it all. We begin to appreciate not only the scale of the universe, but its intimacy. We are made of the same matter, governed by the same laws, participating in a universal unfolding that stretches across billions of light years. Consider for a moment the emotional resonance of this idea. If life exists elsewhere, even in microscopic or molecular forms, then the universe is not empty. It is fertile, alive with potential, and abundant in possibility. Humanity is not alone in seeking to understand, to evolve, and to exist. We are participants in a larger story, one that may encompass civilizations long vanished, worlds we will never see, and life forms unimaginable in their diversity. Even in our isolation, there is connection, an invisible thread linking us to the cosmos and to any other life that may exist beyond our galaxy. This perspective also transforms how we approach science and discovery. When we imagine life beyond the Milky Way, we expand our understanding of what is possible. Every observation, every detection of chemical fingerprints, every faint signal becomes more than a data point. It becomes a testament to the universality of life's potential. It encourages patience, humility, and imagination. We learn to accept uncertainty, not as failure, but as an invitation to explore more deeply, to refine our methods, and to remain attentive to the subtle whispers of the universe. And yet, this cosmic perspective is not purely intellectual. It is deeply emotional, almost spiritual. It allows us to contemplate the duality of human existence. We are transient, our lives brief, and our planet small, yet we are part of a universe that is ancient, vast, and astonishingly fertile. The tension between our fragility and the cosmos' immensity creates a gentle, reflective rhythm in thought, a slow awareness that encourages both humility and wonder. In this rhythm, we find a quiet sense of belonging, a recognition that our curiosity, creativity, and consciousness are not anomalies, but expressions of a universe capable of nurturing life. The sense of connection that emerges from this perspective is profound. Humanity has always looked to the stars for guidance, inspiration, and meaning. We have told stories, constructed myths, and sought to understand our place in the heavens. Now, science allows us to extend those stories with evidence, to frame our wonder within the rigor of observation, and to imagine life beyond Earth with both imagination and grounding. In doing so, we experience a continuity between past, present, and potential future, between the mythic and the empirical, the poetic and the precise. Take a moment to imagine standing beneath a night sky filled with stars, each one a distant sun, each potentially hosting worlds and life forms. Imagine galaxies far beyond, whose light has traveled billions of years to reach us, carrying with it traces of chemistry that may have formed life. Feel the simultaneous immensity and intimacy of existence, the awareness that we are part of a larger process, connected across time and space, yet here, now, capable of thought, reflection, and wonder. In this space, the boundaries between science and imagination blur, leaving only curiosity, awe, and a gentle, meditative contemplation of existence. The cosmic perspective also encourages ethical reflection. When we see ourselves as part of a broader universal tapestry, our responsibilities toward life, both on Earth and potentially beyond, take on new weight. The fragility of life, the rarity of conscious experience, and the preciousness of our biosphere are amplified when contrasted with the immensity of cosmic potential. We are reminded that our actions have meaning, not only in immediate contexts, but as expressions of stewardship within a universe capable of fostering life. Even as we imagine life beyond our galaxy, we are reminded to care for the life that we know intimately. Moreover, this perspective fosters a sense of continuity and resilience. The processes that give rise to life, the formation of stars, the chemistry of molecules, the coalescence of planets, operate on timescales far beyond human comprehension. By contemplating life beyond galaxies, we appreciate that existence persists, that chemistry unfolds patiently, and that the potential for life is enduring. Humanity's brief moment is framed within a narrative that stretches billions of years. A reminder that life is not fleeting in a cosmic sense, but part of a persistent universal process. And yet, for all its grandeur, the cosmic perspective is gentle. It does not overwhelm with immediacy, nor does it demand answers. Instead, it invites reflection, slow contemplation, and a meditative awareness of our place within the universe. It allows us to hold uncertainty without anxiety, to appreciate scale without fear, and to imagine life beyond Earth without despair or hubris. There is comfort in the awareness that we are part of something larger, that our curiosity is shared with the cosmos itself, and that our small flame flickers within an expansive, luminous night. Finally, the cosmic perspective is a bridge between science and imagination, between observation and wonder. It is where the meticulous measurements of telescopes and spectrometers meet the human longing to understand, to connect, and to dream. By contemplating life beyond our galaxy, we expand our sense of self, embrace humility, and cultivate awe. We learn that our smallness is not insignificance, but a point of participation in something immense, enduring, and beautiful. In this awareness, we find both solace and inspiration, a gentle rhythm that encourages patience, reflection, and quiet curiosity. And so, as we linger in this perspective, we recognize that to look outward is to see inward. To imagine life beyond our galaxy is to imagine ourselves within a universe that is generous, patient, and capable of nurturing life. We are not solitary sparks lost in a void, but part of a constellation of possibilities, a living note in a symphony that has been unfolding for billions of years. Our smallness is embraced, our curiosity affirmed, and our wonder renewed. The universe is immense, almost impossibly so. And yet within that vastness, the search for life beyond our galaxy quietly persists. NASA's telescopes scan distant galaxies, collect photons that have traveled billions of years, and analyze chemical signatures that whisper hints of possibility. These signals, though subtle and sometimes ambiguous, are reminders that the story of life may extend far beyond Earth, beyond the Milky Way, and perhaps even beyond our current understanding of time and space. We do not yet know if life exists in these far-flung galaxies. No telescope has returned definitive evidence of organisms dancing beneath alien skies. No instrument has captured the heartbeat of a distant biosphere. And yet the signs we observe, the complex molecules, the precursors of RNA, the rich chemistry in nebulae and planetary systems, invite reflection. They suggest that the universe itself may be predisposed toward life, that the same processes unfolding in our galaxy could be mirrored in countless others. The cosmos, it seems, is patient, abundant, and persistent in its unfolding. Consider the molecules that JWST and other instruments have detected in galaxies billions of light years away. Amino acids, nucleobases, sugars, the very substances that underlie the chemistry of life, float in clouds of interstellar dust and gas. They have survived the violent births and deaths of stars, traversed the empty reaches of space, and persisted across cosmic time. These molecules are silent witnesses to the possibility of life, whispers carried on light itself. They hint that the seeds of biology may be universal, waiting for the right conditions to awaken, just as they did on Earth. This realization reshapes how we understand both space and time. Life is no longer a phenomenon confined to our planet, our galaxy, or even our epoch. It becomes part of the larger tapestry of the universe, a story woven across billions of years, stretched across unimaginable distances, and composed of countless threads of chemistry, physics, and energy. In this context, humanity's search is not simply a quest for novelty. It is a meditation on continuity, patience, and the persistent creativity of the cosmos. Even the absence of confirmed life carries meaning. The silence we experience when scanning distant galaxies does not diminish possibility. It emphasizes the subtlety of existence, the patience required to witness a universe that unfolds on scales far beyond human lifetimes. Civilizations may have arisen and vanished in galaxies long before Earth even existed. Life may exist in forms we cannot yet detect, in ways that challenge our assumptions about biology, chemistry, or consciousness. The universe, vast and patient, invites us to consider the unknown with humility, curiosity, and awe. There is a quiet poetry in this patience. Life's potential is written in chemical reactions, in molecules drifting across space, in stars that forge elements and planets that cradle matter into the possibility of biology. These processes are slow, intricate, and beautiful, unfolding whether or not we are there to witness them. And in observing them, we participate in something larger than ourselves. We are observers and storytellers, chroniclers of a narrative that began long before humanity, a story that may continue long after our species is gone. The search for life beyond galaxies also unites us in ways that are uniquely human. Across cultures, generations, and geographies, we share the same curiosity, the same longing to understand, and the same capacity for wonder. When we look to the skies, we are not just individuals observing distant light. We are a species engaged in a collective meditation on existence. The chemistry of distant galaxies, the dance of molecules in interstellar space, the gentle flicker of stars billions of light years away, all of these become part of a shared human experience, a reminder that curiosity and awe transcend time, culture, and circumstance. Imagine for a moment the vastness of these galaxies. Each contains billions of stars, each with its own planets, each planet with the potential for water, chemistry, and perhaps life. The light from these stars has traveled billions of years to reach us, carrying with it information about the universe's earliest epochs. When we detect complex molecules in these distant realms, we are not only reading the chemistry of the cosmos. We are reading a story written across space and time. It is a story that invites patience, reflection, and quiet imagination, one that unfolds gradually and rewards careful attention with glimpses of possibility. This perspective offers a gentle lesson in humility. Humanity is small. our lives brief, and our planet just a speck in the cosmic expanse. Yet even within this smallness, we possess the curiosity, the intelligence, and the tools to reach across light years, to detect chemical signatures that hint at life, and to ponder our place within an immense universe. The search itself becomes an act of wonder, a meditation on existence, and a recognition that being alive, aware, and curious is already a remarkable participation in the cosmic story. Take a moment to reflect on the subtle joy of possibility. Life may be discovered tomorrow, or it may remain hidden for 1,000 years, waiting for instruments we have yet to build or minds we have yet to imagine. Either way, the search itself is a form of connection, a bridge between humans and the cosmos, a reminder that we are part of a universe capable of sustaining life, curiosity, and reflection. The act of searching unites us, encourages patience, and fosters awe, showing that the process of discovery can be as meaningful as the discoveries themselves. The story is still unfolding. Every new observation adds another stanza to a cosmic poem. Each detection of complex molecules, another note in a symphony that spans galaxies and epochs. The universe is patient, but it is also generous. It offers glimpses, hints, and possibilities, inviting us to participate in the narrative through careful observation, reflection, and imagination. The faint chemical fingerprints of distant galaxies, the slow dance of atoms forming molecules, and the persistent, quiet creativity of the cosmos all remind us that life's story is far larger than any one planet, species, or civilization. And in this unfolding story, there is beauty. The universe, in its vastness, is alive with potential. Stars explode and scatter the elements of life across space. Planets cradle molecules that may one day spark biology, and galaxies harbor chemistry that predates our own solar system. The narrative is slow, patient, and immense, but it is not cold. It is alive with possibility. By contemplating this, we find a sense of connection, a gentle awareness that our curiosity, our wonder, and our imagination are part of a universal rhythm that stretches across billions of years and trillions of stars. We are participants in this rhythm, even as we sit quietly on our small, fragile planet. Each telescope pointed skyward, each spectrum analyzed, each faint detection recorded is a step along a journey that connects us to the universe, to its chemistry, and to the possibility of life beyond what we can see. Even without definitive proof, we are already part of the story, observing the universe, reflecting on its processes, and meditating on the meaning of existence. The search itself is transformative, an act of participation in a cosmos that is patient, immense, and astonishingly alive. And so, we arrive at the edge of wonder, where curiosity meets patience, where science and imagination join hands, and where the universe invites us to linger. Whether we find life tomorrow, in 1,000 years, or never in our own lifetimes, the act of searching unites us. It reminds us that life, possibility, and discovery are not solely about confirmation. They are about awe, reflection, and the gentle joy of contemplating the unknown. The universe is vast, patient, and full of potential, and in that realization, we find both humility and comfort. Take a deep breath and let your thoughts drift among the galaxies. Picture molecules forming in distant nebulae, stars scattering elements across cosmic distances, and planets quietly nurturing chemistry that may one day blossom into life. Somewhere, far beyond the Milky Way, life, or its potential, exists, patiently awaiting the right moment to emerge. And realize that you, here and now, are part of a species capable of noticing this, capable of reflecting, dreaming, and participating in the story of the universe. The universe, immense and patient, whispers possibilities to those willing to listen. Each discovery, each molecule, each observation is a note in a cosmic melody that continues beyond human comprehension. The search for life beyond our galaxy may never yield definitive answers, and yet in the searching itself, we participate in something profound. We cultivate wonder, reflection, and connection, recognizing that our curiosity and awareness are already a form of participation in the universe's ongoing creation. And now, as the light fades and the questions linger like stars in the night, we can rest in awe. Let your mind drift slowly across galaxies, over nebula, and into the quiet chemistry of the cosmos. Feel the patience of the universe, the immensity of possibility, and the gentle connection between curiosity and discovery. The story is still unfolding, and we are part of its quiet, ongoing rhythm. So we linger here, quietly, in the stillness of thought, in the soft wonder of existence, and in the gentle awareness that the universe is alive with possibility, waiting, patient, and endlessly profound.